sessions going to be here. So you see that there are 3 live sessions per week. So first session is called as an activity session. Second is called as solve practice assignment session, and third is like solve with us sessions, wherein it's, say, you can call that as an graded assignment session, something like this, because you will be given a graded assignment questions similar to graded assignment questions. So that will actually help you to solve your graded assignments. Like similar model questions will be made and you will be asked to. So how we will be doing today's session, or let's say the next session as well, is like basically we'll be discussing you some of the concepts first. So let's say today we are going to discuss, let's say, on activity. So as you would have gone through the content, so you would see that there is something called a basic definitions of sets, then the notations of sets, right? Then you would have come across, so I'm just telling majorly what is the thing. Then those small topics, something like really, like rational, irrationals, then density of this. And those things are like you can understand, and so that is something we'll not discuss. Then you would see across something called relations and functions, right? And then you would have seen there are so many questions on relations and so many questions on functions. Well, that is the really important part, and we'll try to focus more on that. So what will be today? Today we'll be doing is we'll do first 1 hour. We'll try to complete with 1 hour the discussion part of like what is sets, and then what is the relations and the types of relations. And the next topic, that is something called functions and the type of functions, and some problems on Venn diagram that can be discussed in the next session. So this is how we will do. So what we will do here is, because you see we are very large in number, so if you randomly ask me questions, so it goes in a very haphazard way, and that is something we shouldn't do. So we'll do it in a structured way rather. And I presume like you would have seen the video contents of all the weeks. I mean, of the week 1. Like, can I assume that all of you have seen all the videos? Is anybody here like who haven't seen? You can put it in the chat window. So I can see like you have seen all the videos, and you have, and I also assume that you have attempted practice the activity questions at least. I finished half. Yes, not sir. Okay. So I can see there is a mixture of all this. No, sir, I have not. Yes, not finished, sir. Okay. So you see, I can see a larger, I mean, I can see the mixture of crowds who have actually done, who have not done, and there are some who haven't started, and some have done partially, right? Or some of you have just finished half of it. So no worries. What we'll do here is we'll try to bring everyone on the same page. You can consider this as like, a learning. So it's like you can learn from, of course, the videos as well, but you can consider the same learning happening here, but in a different way, right? And then we can attempt some questions. So usually this session will be more of me giving you more questions for you to practice. So let's say if I'm discussing you some type of relations, let's say, okay, so I might ask you some 7-8 questions on that, right? And then we can try to exploit the definition of that and try to do as much as problem, so that we have the conceptual clarity, right? So I hope this is something everybody understood, right? So no doubt. Okay, great. Like if you haven't completed, we can just we can bring everyone on the same page. All right. So I guess there are others also joining the session, so it's okay. So meanwhile, I can just present my screen and I can just discuss like what we are going to do today. Okay. So this is what we are doing today, and I welcome you all for the very first live session, which is on mathematics for data science, and today's is activity session. So this is something I'll try to cover today. Okay. So you see here on the screen that something basics, like basic concepts of set theory, like what is the definitions of sets, binary relations, and then we'll do something like types of relation. And first we'll understand what is relations, and then we'll go through this, that symmetric relation, asymmetric relation, anti-symmetric relations, identity relations, reflexive relations. I guess I missed one point here. There is something called transitive relations as well. So that is also we'll discuss here, and I'll take you through the activity questions, and maybe then I can go in a number wise in an order manner, And you can ask me if you have any doubt on that. We can just solve it together here, right? So we can do all that. All right. And do not even hesitate to ask a silly question. That is all okay here. So that we all can do. All right. So going prior to this, do you have any doubt? Like if you want to ask me something, you can ask. I can start the session in another 4 minutes at 7:10. So do you have any doubt or something?
Yeah, sir, I have little doubt regarding the console. Uh, I have accessed the academic calendar,
Mhm.
and but I can't access the forum. When I click at that, it says you are not allowed to access this content.
Okay, so
I
what is
have
it?
emailed the technical team, but I haven't received any reply yet. It's been 2 days.
So maybe I can just point this to them. And but over here, let's stick ourselves to the basic mathematics thing only. We'll not go into the admin part and all. So if you have anything admin related queries or like these portal related problems, so you can just try to support. Okay, so support at the rate onlinedegree.iitm.ac.in. So they will take over from there. So that is something we can do. So do you have any doubt in like in mathematics? No, right? I mean, as if now, come on, like you will not have doubt, but certainly you will develop. So let's discuss now the contents of this. So how we will be doing here is it will be like two ways interaction. So I'll be asking you a question and you can give me your answers on the chat window, or you can unmute yourself and speak as well. But let's see how well it goes. If it is more chaotic, then I would advise you to just put it in a chat window. And if not, like we can just, coordinate and cooperate among ourselves. Okay. So first thing, what we'll be discussing today is what is a set. Okay. So first question is set, right? So I think you would have gone through the lecture. So could any one of you can tell me what is a set?
Collection of well-defined
Collection of elements.
Collection of well-defined elements, right? Or well-defined items or whatever. Like, so what is a set then? So it's a collection of well-defined. It's a collection of well-defined items, right? So now what do you mean by well-defined, right? So you can see this well-defined. So what do you mean by well-defined, right? So what all things are permitted actually in set? So generally you write set with some capital letters, right? So we say like let A be a set and it contains an elements, let's say you just have to tell me whether this is a set or not. Okay, so maybe I can just give you a box and then I can ask you whether this is a set or not. Okay, so if I have an element, let's say 1 2 3, okay, so maybe it starts with 0 0 1 2 3 4 5. Is this a set?
Yes.
Yes, it is. So when I'm asking you a question, you can put it in a chat window. Okay, now let's say another set, it's like, let's say Kohli 6. Okay, then let me say something maybe, and then let's say this is fruit. Okay, is this a set?
No.
Why it is not?
Yes, it is.
It is.
Sir, it is.
Sir, it is a set. It is a set.
It is well defined. Now I'll tell you when it is not defined. It may not be in an the same collection of items. It's not required. Okay, so now let's go with another thing. Let's go with another number or like another set C. Now tell me whether this is a set. Okay, so let's say this is 0 0, or maybe not 0, maybe I can just give it as 7 7 7. Is this a set? Is
Yes.
this a set?
Sir,
Yes,
sir,
sir.
it is not because it has repeated items. And
So
Sir,
repeated
it is a
in programming languages, sets contain
now I'll tell you
values in programming language.
once again, can you tell me what is that programming language? Same collection of items. It's not required. Okay. Now let's go with another thing. Let's go with. Okay. So can you? I'll mute all. Now tell me whether this. All right. So you see, this is a set, but essentially when you write the repeated elements and you use any programming language, they will take this in this form, right? Even so, basically, when you say something in a set, and when you say a well-defined, I haven't come to the well-defined part yet. This is just I'm listing the sets like which can be a set and which cannot be a set. So in a set, you can see that repetitions of an element is okay, but essentially what is basically repetitions of an element, it doesn't make sense in a set. Even if I write an element, let's say 7, and write it like some 10,000 time, it essentially means the element 7. That's all. Okay, so but that itself is the set again, right? Now let's go with another set. And here I say, maybe I can just write it in a set comprehension form. Let set D be a collection of X, where X is a even number. Maybe I can say that X is an even number, and X is less than or equals to 10. So is this a set?
Yes, sir.
Yes.
This is
Yes,
also-
Yes, sir.
But this is in a set comprehension form. So basically, this is in a set comprehension form, but you can actually write this set. I mean, you can list the elements of the set D, right? So what are the elements of set D? Can you help me out?
2, 4, 6, 7.
0, 2, 4, 6, 8.
0, 2, 4, 6, 8, 10.
And 10, because 10 is also included, right? So that's
It is not specified whether it is integers or natural numbers.
oh yeah, that's actually a valid point. But you see here, this is an even number, right? So when you just say that, so you just actually tend to have that notation thinking that yeah, it's a natural number, but just for
Sir,
simplicity.
but even numbers are not next to negative form. So
Yeah. Right. You're totally right. But I just told you, like, when we say, so we can just say that X is a natural number. All right. So you see this, so this is what you get here, right? So now you see that this is a set, but here it's a two different notations of the sets, right? So one is in the set comprehension and another is like a set builder or something. So this is again a set, right? So now we understood what is a set, right? Now another set. Set of where D, let's say X. So where X is a set of rich people.
There can be many rich people, sir. So how can it be a set?
Okay, so this is not a set.
The richness also can be depend on perception.
Right, exactly.
Sir,
So this, why this is not a set is, it's because it's not well defined, right? Because your perspective and my perspective will be different, right? Because a rich people, you can say that, okay, he is monetary rich, and you can say that he is knowledge wise rich, but you can even say like, you don't know what is the setting criteria. For a very poor person, the richness may be a person who is, with some lakhs or something, but person who is with the middle class, they might think, okay, the richness is someone, like
Excuse me, sir.
and all that things, which is something not well defined, right? So this is how we can say that yes, this is not a set.
Excuse me,
and
sir.
not well defined. Yeah. Yes. Go ahead.
Yes, sir. Actually, I was asking that if some set is infinite, then can we say that it is not well defined?
No, that is not right. You can say here, for an example, here a set of even numbers where X is an n. So here, so maybe I can take this as an example here. So this is D. Let's call this as E, and let's call this another. So here X, where X is a
Even number.
Yeah, let's say even number. So here even number can be anything. It can take the negative values as well. So that's okay. So
Yes.
can you say this is a set? Yes, this is a set.
Okay.
Beautiful.
And means
This is well
sir
defined,
also. Okay.
right? And how do you write it in a set builder or something? How do you write this?
So basically, if it is similar to like D is equal to like 0, 2, 4, that is the way.
not specified.
Now let's do it here. So now I can say that even numbers are 0, 2, 4, and blah, blah, blah.
And of course, yes.
Yeah, so
But this type of notation is not allowed as per sir, right?
which type of notation?
The last one.
set builder, sir.
Yeah, exactly.
set-
So you
It
say
is not
it
allowed.
comprehension way, right? Yeah, that is right.
Yes.
Yeah, so this is actually wrong to say because you never know, okay, after this, what could be the sequence of this, right? It
Yes.
might be a repetitions after this, so you cannot just express it in this way, but just to tell you,
Yes.
okay, this is what it means. So, okay, so we understood what is a set now, okay? So now there is something called, okay, so
Sir, actually, how can I check that I have logged in through the IITM mail? Means I don't know how to check that.
that is something you'll have to check with your Zoom tool.
So means I am not finding any setting where I can see that.
Okay, so once you log out from this, you can just actually see with what ID you have logged into your Zoom, so you will identify that.
Okay, got it, sir. Then I think that it will not be this.
Yeah. So, okay, so is order important in a set? Okay, so now if I have to tell you this set, let's say this is set G,
No, sir.
and it contains an element 1, 2, 3. And let's say you have another set F, and it contains an element 3, 2, 1. Is
No,
F
sir.
and G same?
That is not necessary.
Yes, sir, they are same.
Yes.
So actually this set, yeah, this set G is a subset of H. I can say
Both
that.
are same.
Or you can say, and G is actually equal to H, right?
Yes.
So you see this, this is what you can see. Like the order does not matter. So
Duplicates don't matter in case of sets.
yes. So even the duplicate does not matter. So you can just make a note of this. So maybe you can say that what you can say from here is the order does not matter in a set, right?
Sir, can you give example of functions of sets or set of functions?
Functions of sets.
Sorry, set of functions.
Set of functions.
Yeah. So for example, x or x square or x cube.
Okay, like that.
Set. Yeah.
But again, you will have to really think in what way you want to define it, right? So this turns out to be like, you can say that
Some of the questions are having similar like
which
functions. For example, x comma y and y is equal to x cube or x square.
Okay, I got
something.
it.
That
Yes.
explicitly list out the set for some values, the constant that is given there.
Yeah. So, and what is
Converted
the,
into
just a minute. Duplicate elements are allowed or not allowed in a sets?
not allowed.
It's, you can
Not
say
allowed,
that,
sir.
yeah, it's not allowed, but when you write those duplicate elements, it's essentially mean that the repetitions is something not being counted. So duplicate elements are not allowed. Okay, so this is what some basic understanding of sets we got it. Okay, so now there are some other concepts that we should know, and like what are some basic things like. I can just take another page. Yeah. So now here, what do you mean by proper subset and what do you mean by improper subset? So what do you mean by proper subsets? These concepts, okay? Now let's say this is of two types. Let's say proper.
If all the elements of set are contained in set B.
Okay, just a minute. So this is proper subset, and then you have something called improper subset. So what do you mean by proper subset?
If all the elements of set A are contained in set B.
Symbol notation and this.
Sir, if the set does not contain null set, then set itself is known as proper subset.
Okay, so maybe let's just discuss this example. Okay, so one example for this is, let's say we have set A which contains element 1, 2, 3. Okay, and now we have another set B which contains element let's say 1, 2, 3, 4. Okay, or let's say this is a 5 as well. Okay, so can I write this in this form? A is a subset of A is a proper subset of B.
Yes, sir.
Can I also write this in this form? A is a improper subset of B.
No, sir.
Actually, you can write this both.
Oh,
Okay, we'll tell you why. So you see this.
I know. I guess it is because few elements of B are not present in A.
Oh, okay. So I'll give you another example. So let's say I'm taking another example, example number 2, and let's do. So I have set A. No, not say. Let's call it as set C. Okay. So I have.
Means remove the screen's participation, sir.
Sorry, what?
Screen participation of people remove. Yes, sir. I'm not able to see the proper screen of this right there.
Oh, you cannot see my screen, is it?
Not I see, sir, but I not properly see the B subset of.
Oh, I see. Okay. So maybe I can zoom a bit. Now it's visible.
Yes, sir, but participation of people also visible the screen.
Okay, so that thing you have to minimize that.
Okay, sir.
Yeah. So try doing that. So now you see I have another set D, and I say that D set is 1, 2, 3. Can I say that C is a proper subset of D?
No, sir.
I cannot say this here. But can I say that C is an improper subset of D?
Yes, sir.
So what do we understood from here?
Sir, in proper subset, there must be an extra element, sir.
In proper subset, let me take another example.
A should be a subset of B, means some elements of all the elements of A should be contained in B, but not vice versa. If that is true, then it is a proper
There must be
subset.
at least one element which is not in B. Like that.
The proper subset does not contain null set and set itself, sir.
Yeah. Okay. So could you just tell me? Could you tell me this? Is C is a proper subset of D?
No, sir. I don't think.
Is which among them is right? The first one or second?
First one.
First one.
First.
No.
None of them is right.
None of them.
First three is not present.
So I think with this example, you would have understood something. Okay. So now let's understand this and let's summarize what we understood. Okay. So now when we say that this symbol, what do you see? So okay, I'll mute all and I'll just speak now.
Sorry.
So you see this in example number 1. You see I have two sets, set A 1, 2, 3 and set B 1, 2, 3, 4, 5. And when I say A is a subset of B, so what do you mean by subset of B? You can actually compare this with this symbol. You can think of this in that manner that A is lesser than B. I mean, this will help you to understand this this concept. So just think that when I use just this symbol, you see this proper subset symbol. So you can just keep it in your mind that A is lesser than B, okay? But it is not equal. If it is equal, then I cannot use that symbol, okay? So this indicates that this is strictly less than this one, strictly less than, and this is like less than or equal. It can have both, right? So now you see in the first example, A is less than B. Just think it in that way, but I have to make sure that I have all those elements, right? When I say less than B, but I have to make sure that it is actually a subset of it. That is something I have to make sure that. And then I have to also make sure that A is less than B. And I have to make sure this thing as well that they are not equal, right? So you see that A is actually not equals to B because you see the element 4 and 5 are missing, right? And you see that A is strictly less than B. Why do I say that strictly less than B is? Because you see that there is no more elements like 4 and 5 in set A, right? That's why I can say that A is strictly less than B, right? And what about A? What about the second option? A is less than or equal to B. So can I say that yes, that is less than or equal to B because there is a two condition coming in. It
Yes,
can be less than
both less than
or,
equals to.
right. So these two conditions are coming in here. So then I can say that yes, both of these are correct. Now you see in the example 2, when I say that set C is 1, 2, 3 and set D is 1, 2, 3, can I say that C is less than D? I cannot say that because they are actually equal if you see, right?
Can you
but there is no equality, and I can even say that they are not strictly less than, right? So when I use this symbol, you see this proper subset symbol, this says that it is strictly less than. Strictly less than means it has to have lesser elements, but not all the elements. Okay. So when I use this symbol, it must have a lesser elements, but not all the elements, right? So you see this actually you see this C contains all the elements of D. So I cannot use this symbol. Rather, I would use this symbol, right? And at that point of time, I call this as an improper subset, right? So subset, what do you understand by a subset is? Subset is some part of something, right? So when we say proper part of it, that is why we call it as a proper subset, right? And when do we say improper subset? Like though it is a part, but it may be a full of it, right? So that's why we call it as an improper subset. I hope this is okay.
In equation 2, C could be a
yeah.
C could be a subset of D, and D could be a subset of C also, no?
Yes, you're right. That is totally right. Yeah, you can say D is a subset of C as well. That is also possible. Okay, so now, but here I have just listed those examples. So let's think it in that way. Over here, you see in example 3, I have 3 elements, 1, 2, and 3. And you see the set D contains 1, 2, but not 3. Notice that. And 4 and 5. So can I say that C is a subset of D?
No, because 3 is missing.
Because 3 is missing in your set D, right? So I cannot say that this is a part of it, right? So even if there is one element which is not a part of the bigger element, or for which it is being a subset, it is not a subset of it, or for which it is trying to be a subset, or not, maybe the trying word is wrong, but this is not a part of it because it has got some other elements as well in this set, right? So you cannot think of intersection here because those are different concepts. You cannot think of intersection and say that as a part. It is just that you are comparing the whole, this set with that set, okay? That's why you say that C is not a subset of D. I mean, C is not a proper subset of D, right? Is C a improper subset of D? Actually not, again, because you see the elements are not same, and even the elements are not same, and you see the cardinality of elements C and D are different, right? Agree?
So improper subset depends on cardinality.
Yeah, you see, what is the cardinality of C? In example 2, 3, what is the cardinality of D? 3.
It's 4.
And even the elements are same, right? So you have to make sure that, like, see, improper subsets, it did not be that the cardinality should be same. But what I meant to say here was, like, yeah, it need not be, because you see in the first example, the cardinalities are different, but still it is a proper subset, right? Yeah.
Yes.
Okay, so now let's move on to the next topic, because we have a lot to discuss. And see, eventually what happens is, I know, like, whatever doubt you have, eventually it will get cleared by yourself as we are discussing more and more, right? So, so keep your doubt for the end, we can discuss that. Now let's go with the another concepts. When do you say two sets are equal? Okay, so now I have another question. When do you say two sets are equal? Okay.
When the number of elements and the name of the elements are the same.
Name of the elements.
So when both the sets are exactly same.
Yeah.
Yes.
When both the sets are subsets of each other. Each
Yeah.
and every element of set are equal.
Okay, so there are two conditions. So maybe you can say this as an answer, and then I can say there are two conditions. So first is what? Let's say two sets, like
subset of
Cardinality should be same.
When A is a subset of B and B is a subset of A.
Yeah. So consider two sets. Maybe we can say this. Consider two sets. Two sets. Maybe set A and set B. Okay. So now you notice this, and let me say that. Okay, maybe not say this, but I can just give you the condition. What is the condition? So condition is A should be a subset of B, and there is an AND condition. B is a subset of A. This also implies that A is actually equals to B. So which is what, this is what we are finding. Basically, this implies that A is equals to B. So let's see with an example. So let's say this A contains an element. Let's take our favorite element, what B. And let's say this is our B and it contains an element. Let's say again 1, 2, 3, and 4. Okay. So is A improper subset of B? Yes, this is right.
Yes.
Can I say B is an improper subset of A?
No.
No.
No. So this AND condition is not fulfilled, so I cannot check for this. So then I can say that they are not equal. So in this case, is A is equal to B? A is not equals to B, right? Now this is our example 1. I hope you understood this, right? Now let's go with example 2. If you didn't understood, I guess you will understand here. Let's say here, I'll list some name here rather. Rahul, maybe, and then I can take Rita. Okay, and now let's take set B, and then I have Rita, Rahul, Abdul. Okay. Now you have to tell me, is A a subset of B, or is this an improper subset of B? A is an improper subset of B. Is this right?
Yes, sir.
Yes, sir.
Yes, sir.
Now, can I say B is an improper subset of A?
Yes.
Yes,
Yes,
sir.
sir.
Okay. So can I say that A is equal to B?
Yes, sir.
Yes, sir.
Why? Because the elements are same, and you see the cardinality is same. Everything is same, right here. So I can say that yes, A is equal to B. So I hope you understood with this. I don't think there
Excuse me,
is
sir.
more explanation needed here.
Improper can be substituted by subset. It is the same thing, improper and subset.
Could you come again?
Improper and subset are same thing.
Proper subsets are same thing as well?
No. You said that A is A is an improper subset of B. Okay.
Correct.
So I am asking that improper and subset is the same thing.
So when you say you cannot actually say A is a proper subset of B, because you see this here the elements are same, exactly they are same, right? So I cannot use this symbol, that just proper set symbol, right? You see in the first which example? In the second example over here, right?
No, I am asking does improper is equals to subset? That's what I am asking.
It's a type of a set, right? Improper subset.
Type of a subset.
Sir, even I have one query.
Yeah.
Sir, when it is said that A is an improper subset of B, does not implies that A is equal to B, because okay, because only it can be improper subset if it is equal, as we have discussed.
Because you see in the first example, this should actually tell you that it need not be equal, right? Okay, so now let's quickly move.
Sir, one doubt, sir.
Yes, sir.
Sir, actually, for proper set, we denote it as and not equal to sign below the subset.
So you can even say that. You can even say that here. So maybe I can use this symbol here and say this. So here, when I'm saying this, I can use even this, or I can say this. Okay, both are same.
Sir,
okay,
sir,
so
can you take an example of blood relation and explain this same thing?
Okay, you can say, let's say A is a father of B. Okay.
Okay.
Now, can I say that B is a father of A?
No, sir.
No, actually, it's a wrong example here. So, what do you want me to ask here? So, basically, you want me to give you a set wherein I'm saying you that,
like A is 3 years old, then B or like that, something like that.
Maybe
or A
we'll
lives
take
in
up,
the same.
it's better when we take up some examples later on and then discuss. Then
Okay,
that will be, then it will make more sense.
Sir, I
Actually,
have a
there
doubt.
was one.
Okay, no problem. We'll take up that question as well. So,
Sir, I have a doubt. Sir, can I say set A and set B are equal when both of them are not proper sets but are improper sets?
Yeah, you can say that.
Yes, sir.
Okay, so now let's move on to the next topic. Basically the similar topic only. So now concepts like what do you mean by cardinality of set? Okay, so just a heading, cardinality of set. So it's just to bring all of you in the same page. That's why I'm discussing here. So thereafter we can just move to the next topic. So here, let's say I have set A and it contains 1, 2, 3, 4. Okay. So what is the cardinality of set A?
4.
So what do you mean by this? Or maybe
number of elements present in a set.
Items in a set. Number of elements in a set.
Or maybe I can just give 0 here. Okay. What is the cardinality of set?
5.
Okay. So what do you mean by cardinality of a set then?
Number of elements present in a set.
Yeah.
The total number of elements.
Unique
Number of elements.
Number of elements in a set.
So in very simple language you're writing, you should be able to understand. So this is what you mean by cardinality of a set, right? So what do you mean by, so this is something we understood, right? So what do you mean by, so if I have a set A, maybe I can just discuss what is a power set now. So I hope you know what is a power set, but still, let's say I have a set A, and then we can come to the definition part of it. Now I have set A. Let's say I have set 1, 2, and 3. Okay. So could you tell me
Set
from
of
this subset?
subsets.
Okay, just let me talk now. So from this set A, how many subsets can I create? Right?
Sir,
So can
8.
I-
Eight, sir.
Eight.
Eight,
So,
sir.
8.
so could you help me out? First set is like a empty set, will not
Yes,
have
sir.
anything.
It's nine. It's nine, sir.
So then set
One,
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 1, 2,
Sir,
3,
1,
1, 2,
3,
3
then
three,
1, 2,
and 1, 2,
2,
What?
3,
1, 2,
and
right?
3.
2, 3,
1.
So I can have
1,
this
2.
1, 2.
1, 2, 1, 3.
3.
1, 2, 1, 3, 2, 3.
3, 1, and last 1, 2, 3.
2, 3.
3, 1.
3, 1.
What is that? 3, 1.
3, 1.
Okay.
Sir, here the two variables named A2 equals to 1 and A2 equals to 2.
Hmm?
A2 equals to 1 and A2 equals to 2.
A2 equals to.
So while writing, you made a
Sir, you have
small mistake.
means repeated A2 2 times.
A2 was repeated twice. A2 is
Oh,
equal
I
to
see.
1.
Okay. Oh. Okay. I'm sorry. So yeah. So this is going to be 3, 4, 5, 6, and 7. So at last, it's going to be A8, and it contains what all elements 1, 2,
1, 2, 3.
3.
right? So now you see how many elements did we get? Countably 8. Right?
8.
So how do you get it? So it's basically how many. So what is the formula
2
to get
raised
it?
to power n.
2 to
2 raised to power n,
Can you
where
mute
n is what?
N is number of
sorry
elements.
to interrupt, sir.
Where n
Number of
is
subsets.
Generally to all.
where
Actually,
n is a cardinality of set.
jargons, creating jargons while in meetings, sir. Can you please mute centrally to all?
Yeah, sure. So I'll mute you all, and when I tell you to speak, then you speak. Okay. So 2 to the power of n, where n is a cardinality of set A, right? So now we something understood. Now this will tell you the thing. So now what is a power set then? So power set is a set of all possible subsets of a set, right? So power set is.
Sir.
Yeah, just a minute. If you have a doubt, I'll tell you when to ask doubt. Okay, so just for a while, bear with me. It is a set of all possible subsets of a set. So we understood what is a power set. Okay, yeah, now you can ask me. Yes.
Sir, आपने वो
Is A1 equals to a Greek letter?
A1. This is just to indicate that this is an empty set, or you can just represent it in a this way. It's a null set.
Empty set or 0.
Yeah. Okay.
Sir, in that A5, A6, A7, A8, आपने double bracket क्यों डाला है?
Because I want to indicate this as a set. Set. Understood?
No, sir.
Up to it out. ठीक है अभी?
Sir, but does double bracket doesn't indicate power set?
So you see, basically it tells you what is. It's basically a set, right? A set inside a set, isn't it? It's just that, a simple thing. If I would have used this bracket, you would have told, okay, what is the order of this then, right? So the order would have mattered. So when I use this set symbol, when I use this symbol, what does matter here is, I mean, what can you talk about this is, it's basically like, I can happily say that, yeah, this element can be rearranged in itself. So if I have to write this, I can write this in this manner also, right? Right? I have a freedom to do this, right? You understood?
Yes.
Yeah.
Yes, sir.
Right? So that's why it's the same thing, right? It's just the set we are representing inside a set. That's it. Okay. So so this is about a power set. So now let's go and discuss more, like what do you mean by, so this is something we discussed, like, okay, what is a set? And with set we understood, okay, what do you mean by cardinality of a set and power set, and then we also discussed the definition of a set in an extensive manner. So now let's go with switch ourselves to a concepts like, what happens when two sets are multiplied.
Sir, I was disconnected.
Okay, I think if you would have disconnected for a while, you did not miss the point. I was just summarizing things. I was just telling you all that, right? Okay. So now let's just go with. Now let's just discuss this. Now I have a set A. Maybe I can just give you an heading and say that, okay, this is some operations on set. Maybe I can say this. On operations on sets. So what we can do here is, so now you see this, when I say this, let's say if I have a set A and it contains elements, or standard elements, 1, 2, 3. Now I say another set B and it contains an element, let's say A comma B. Okay. So now if I have to multiply this, now if I do this, A times B, I get another set. Okay. So when I do this cross product between A and B, this itself is a set. And what are the elements of this set? It's going to be 1, comma A, 2, comma
A, 3, comma A,
3, comma A,
1, comma A,
1, comma B.
Now similarly you can do it what? 1, comma
B, 2, comma B,
okay,
3, comma B.
It's going to be 3, comma B. So how did we get this? Essentially, what are we doing here is we are just doing this set A. This is our set A and it contains 1, 2, 3, and this is our set B and it contains what? A and B. And what are we doing? We are doing this cross multiplication. This is B. What are we doing? This mapping from here to here, and it's just that you're finding this.
Right? It's Cartesian product, sir.
Yes, it's called Cartesian product. So what are you doing here is this product is called as Cartesian products of A and B. You see this? This is Cartesian product of A cross B. Okay. So now this is something we should understand. So when we do this, we have a two sets. Let's say set A and set B. And when you do this Cartesian product of set of both the sets, you tend to get these kind of elements. And this itself is a set again. So you notice that this is set. Could you tell me what is cardinality of A cross B? Quickly.
6. It's cardinality of A into cardinality of B.
So cardinality, so this is essentially cardinality of A times cardinality of B, which is
B. But here order matters.
I'll come to that part. Okay. So could you tell me if I have to generate a subset, can you tell me what would be, maybe I can just ask you, what is the cardinality or maybe not cardinality? Yeah, but okay. What is a cardinality of power set of A cross B? What will be?
2 raised to 6.
2 power 6.
So how do we do this? This essentially means 2 is a 2 to the power of cardinality of A cross B, right? This is what you did, right? So this is something, it's just that what we discussed, so I just told it to you. So now what are some characteristics of this Cartesian product? Now you see this, if you have to discuss some characteristics over here, characteristics of what? Cartesian products, right? So what do you see from here is, in this Cartesian product, when I did this, you notice this, when I did this A cross B, what did you see this? This element was coming from where?
A.
And what about the second element?
B. It was coming from B.
Coming from? It's coming from set B, right? So that is something. So can I say that? So how can I just actually formalize this and say this? So when I do this Cartesian product, the first element is from set A. So if I have to express this, A cross B is a set, right? Such that if I say this A comma B, maybe, or maybe let's just use this symbol. It's a collection of set X. So maybe Cartesian product of A cross B it contains all such elements such that all such elements XY such that where X belongs to what?
X belongs
set
to set A and
and
Y belongs to set B.
Y belongs to B, sir.
Yeah, so I can say this, right? So now you see this. So can I say that order matters here?
Sir.
Yes, sir.
So the order is very important, right? So order matters here. But in a set, did order matter? No, right?
No, sir.
No,
Right? So
sir.
here I can say that order matters here, right? So that is something I have to understand. So I cannot say this set as, I cannot say this A cross B when I'm, what do you mean by order matters? I cannot list this element A comma 1, right? It essentially means what? I am doing B cross A then, right?
Yeah.
Right?
Yes,
I'm
sir.
not doing A cross B at that point of time, right? So this is what it means. All right.
Sir, excuse me, sir.
Please
So you said 1 comma A and 2 comma A cannot be changed, but we can change the order of 1 comma A. Then we can write 1 comma B, then 2 comma A, 2 comma B, 3 comma A, 3 comma
1
B.
comma A.
This order
and
can be
what?
changed.
Yeah. That order
these elements can be changed.
One
Yeah, of
one
course,
A,
this
one
can
A,
be
one B,
changed.
2A, 2B, 3A, 3B can also be returned. So,
Okay, so
order does
okay,
not
so,
matter. Order
so
does
the
not matter
confusion is
there.
here. So order matters for, so order matters for this product, right? So this, what I meant was the order matters for this
XY.
element. So the order matters for
XY.
Yeah.
Sir.
Yeah. Please go ahead.
Sir, if we multiply three sets like A cross
Do you have
B
any
cross
doubts?
C.
No, right?
Yeah, it's okay, sir.
Sir.
So now what? It's just this A cross B. Now what else I can do with this? Can I do this as well? A cross B cross A. So let's discuss this.
Yes, sir.
How to happen. So how
Sir,
will that
it is
happen?
also a Cartesian product.
It is yeah, you can say that it is a Cartesian product, but it's it's a Cartesian product of three different sets, right?
Triples.
Yeah, so you get triplets. You can say you are generating triplets here. So what are the elements of A here? Basically 1, 2, 3, right? And what is your B element?
A, B.
A and
AB, sir.
Just for simplicity, I'll write this as B again because we have to list those elements. So here, what do you have? A, B, and again I have what?
1,
B.
2,
No.
A, B, A, B.
So now what? When I'm doing this, A cross B. So could you help me out? List those set. A cross B cross B. Could you help me out list this? So how is this going to be? So maybe we can just go it in order. So this is going to be 1 to A, and this A is going like this. Yes. Right? So I can take this 1 A, comma 1 A B. Right? So I can list them. Now what I'll do is this one can go to this. So now what? From here, this can again go to this and this. Right? So I can do this 1 B A,
1 B.
B. Likewise, I can go with 2 and generate the all. So now I can just leave this as it is and not solve this. So could you just tell me what is the cardinality of A cross B?
12, sir.
12.
This essentially means cardinality of A times cardinality of B times cardinality of B. So what do you mean? What do you
12,
get?
sir.
Yeah, right. So 3 into 2 into 2 into 2 is 12. So it's 12, right? So this is a set, right? This is a set, isn't it? Now, if I have to generate a power subset of it, so what will be the cardinality of that power subset?
2 to the power 12.
2 to the power of 12, sir.
To the power of 12, sir.
So now, if you know this, then you can actually answer some of the questions in your, in your quizzes as well as assignments later on. So now you see this, we understood these things, right? So now from here, one basic things that I would like to discuss here is there's something called binary relation. Yeah.
Sir,
Sir,
we call A cross B as a Cartesian product. So what we call A cross B cross B?
See, you can even call this as a Cartesian product, but it is a Cartesian product of three sets.
Okay,
so
sir,
when I say a Cartesian product, it will not be just A cross B. It can be A cross B cross C cross D or whatever, right? It can have a number of sets. It will not be just two. Okay.
Okay, sir.
Right. So now let's go with another thing and just come to our new concept, that is relations. Okay. So now what do you mean by this? Now what is this relation, right? So I'll just give you a formal definition here. a relation is basically a subset of Cartesian product subsets, right? So a relation is, now having known this definition, you will have to tell me whether they are relations or not. Okay, a relation is a subset of Cartesian product of,
Sir, which subset, proper or
I'll tell you.
improper?
Okay, that is something we will not list here. Maybe we can list it. That is something you can identify. But when we say generally a subset, you can just understand that it is just a part of it. Okay, so it can be both. It can be both. But just normally, what do we say? It's a subset, right?
Okay.
A relation is a set of a relation is a subset of a Cartesian product of a set, right? So now, how do you actually notate this? So how do you say this? R is a subset of A cross B, right? Or you can say that or you can even say that R is a subset of A cross A, or I can even say that R is a subset of A cross B cross C. I can even say this. I can build a relation, right? So now what you notice here is this R, let's say this, maybe I can use a bracket here and then I say this. Maybe I can use this bracket and say this. This is what I'm representing here. A, B, C are sets. Okay. So now you see this, we understood what is a relation and how do we represent. So what are we saying here is a relation is a subset of Cartesian product of set, right? So it's just the Cartesian product. And in the previous example, we have done a Cartesian product, right? So now let's see this. Now let's take an example here. Let's say example 1 and say this is a set A and it contains element 1, 2, 3. Okay. And I have another set B and it contains an element 1, maybe not 1, 2, but I can just say it as, again, let's say take it as A plus AB. And we listed those elements, right? So this is my Cartesian product, right? A cross B. When I do A cross B, I get this, right? And we know what are these elements? 1A, and we know this 1B, and blah, blah. Yeah, let's not, we know this, how to do it. So let's not discuss that here. So A cross B is this, right? Now, when I'm saying this, R is a subset of this, right? So R is what? R is a subset of A cross B, right? So it can, so can I have this R and I can just say I have just this element. Can I still say this is a relation? Can I say this is a relation?
Yes, sir.
Yes, sir.
I can say yes, this is a relation. Can I say this as a relation, 1 comma B?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir. Because what am I doing here is my relation is mapped from where to where? A is a subset of A cross B.
A cross B.
Okay, so now can I have this relation also possible?
No, sir.
No,
It's
No,
sir.
sir. No, sir.
Because here
It
my
is for
relation
B
is
cross.
A cross B. That is for B cross A. But here, what is my R? A cross B.
A cross B.
So in this case, this is not a relation. So now you see this. Can I also have this? Can I also have this relation and list all these elements? So can I also say that R is equals to, can I just mention this? 1B?
Yes, sir.
Yes, sir.
So, and yeah, so wait a minute. 2A, 2B, 3A, 3B. Can I say this is a relation?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So when I essentially list this, when I list them, I get the same elements. So what I'm doing is I'm listing them all here. So what I'm doing here, this is what I get when I do this Cartesian product. So I've listed all the elements. So I'll mute you all.
Okay.
So you see this A cross B is this. So you see this, is R still a subset of A cross B? The answer is yes. Why? Because you see here, it's an improper subset, right? So all I have is this equal symbol here, right? So look at the definition. R is a subset of B. It's essentially we mean improper subset of A cross B, right? So essentially we understood what is a relation and we saw with an examples and we could happily say that, yeah, this is what. Okay. So now we understood this is what the relation is. Can you tell me what is the maximum number of elements can R have? What is R max?
So 2 to the power cardinality
Six.
of A into B.
That's 6.
6. So it's cardinality of A times cardinality of B. That's all, right?
So, if the last one is also the subset of the Cartesian product of A cross B.
This one.
This,
The
That is
last
A cross B.
one. Okay.
Yeah. What is R minimum?
So empty
One.
set.
1? Can it be 1?
Empty set.
Reset.
Pi.
Can I say 0? No elements at all. Cardinality is 0.
Yes, yes, sir.
Yes, yes.
Yes, sir.
Yeah, I think so. Yes,
Yeah.
sir.
Right?
So
Because,
that represents the empty set also.
yeah, that represents the empty
Empty
set. Can
set,
I
yeah.
say that R being an empty set is a relation of this? The
Yes,
answer is
sir.
yes.
Yes,
Yes,
sir.
sir.
Yes, right? So R min is 0 and R max is what? The cardinality of A cross B. Right?
Sir, I have a doubt, sir.
Hmm?
Sir, but as we have read, like empty set contains one element most.
Empty set does not contain elements.
Sir, but 2 to the power of 0 is 1 no, sir.
So that is a power set,
Okay, okay, sir. Okay, sir.
right? That is different. Okay, so could you tell me then?
Then the R max.
Okay, now one question to all of you. One question to all of you. Now we have less time and I think it's already 1 hour. So we will have to rush now. So could you tell me what is the total number of relations possible? Okay, maybe I'll not get into this part. So, like, I think you can answer that. You can build those things. So that's all fine. Now I'll go to the next topic. That's something called binary relations.
Sir,
Binary relation. Yes,
Sir,
yes.
sir, answer to the earlier question is the power set.
So 64 was the answer for previous one.
So if in R minimum we are including null set, then R max must be 7 cardinality because 6 does not fit
No,
with
do
null
not
set.
get confused with the power set. No, do not get confused with the power set.
Okay, sir.
Yeah, that is different. Okay, so what do you mean by binary relation? So binary relation is basically, maybe I can just write a definition. You will find that you have already learned this. So a binary relation R, so maybe I can say R is a binary relation. I can use the symbol R. So a binary relation R from set A to set B.
Sir, will R minimum always be 0 in every case,
Yes,
in every
yes,
example?
Yes, yes, yes.
Okay, okay, thank you.
Yeah. Is a set of ordered pairs where first elements, this is something definition of your relation itself, right? Where first element is from set A and second element is from set B. So now what do you notice here is, so this is a binary relation. You cannot have A cross B cross A. That becomes a trinary relation, right? So here you will have just Cartesian product of 2 sets. Okay. So this is what. All right. So now you see this. Hereafter, I'm going to discuss some types of relations. Okay. So now I'll discuss some types of relations and I have mentioned a lot about it, right? So types of relations, and you might have many doubts saying that, okay, why you will have only with them and not with others. Maybe you can just have that doubt later on. So you see this, I'm going to deal some types of relations. And when I'm discussing these types of relations, I will be doing this. R is a subset of A cross A. Okay. So types of relation when R is a subset of A cross A. So what you see is I have the Cartesian product of the same elements. It's not that R is a subset of A cross B. Even if I say this B is actually a subset or B is actually equals to A. So this is what I mean. So what I'm doing is I'm just taking a set A and I'm doing the Cartesian product of that set A and I'm building a relation. So can I build a relation like this? I can build, right? We have learned it here.
Yes. Yes, sir.
So what I'm doing is I'm just taking this case. I'm just taking this case and I'll discuss all the type of relations. So now you might have doubt saying that What about the type of relations wherein we have these elements? Can we have a type of relations for this as well? The answer is yes, but they may not be the relations what I'm going to discuss, right? So this type of relation is for this. Clear?
Yes, sir.
Okay. So having known this, let's switch on to that part, types of relations, and I have written some definitions.
Sir, can I ask a question, please?
Could you ask? Okay, so yes, please do ask in a quicker way.
Sir, can you explain that star operator of binary relation, which sir told in the lecture?
We can take up that at the end. Let's go it in a flow and finish our this thing, and then we can take up in our activities when we are coming there, and we can finish it at that point. Okay, so now you see that something I have written already, because I don't want you to waste more time for writing here, and we can do more things here. So something I have written here. So hereafter, as I told you, that all type of relation will be R is a subset of A cross B, and this is where I'm discussing these types of relation. So now I hope if you have gone through the videos, you should be able to answer this. So I want you to quickly answer this question number 1. Okay. Zoom out a little. Is this okay? Should be okay. Yeah. So yes, quickly give me the answer for this. Put it in a chat window. I want to see how many of you can answer this. Consider a set A which contains element rat, cat, dog, and you have a relations in A cross B such that R contains elements rat, rat, cat, dog. Then you have dog, cat, rat, dog. Now this is your set R, right? Or a relation R. Which among the following is correct? Now you have 4 options. R is a symmetric relation, R is a asymmetric relation, R is an anti-symmetric relation, and none of the above. So I want you to answer.
Can you explain what is asymmetric?
Yeah, I'll do that. But right now I want you to see how much you know. Like how many of you can answer.
I think it's symmetric reaction.
Just put it in a chat window and I'll go and discuss that. Okay, then I can see this. Most of you are giving answer as 2. Some of you are giving answer as 3. None of the above also is coming in. Okay, so I can see that yes, most of you are giving answer as option 2, asymmetric relations, anti-symmetric relations, and also symmetric. Nobody is telling it's symmetric. So I guess you are very much fine with the symmetric definition then, and that's why you're not telling this. So you have confusion with asymmetric and anti-symmetric. So that's all. Now we can just discuss this, and I think over here the answer is maybe you yourself will tell me, not right now, but let's
Sir,
first
I think
discuss.
option 1 should be correct.
Okay, let's discuss this. Maybe you, what is your good name? What is your good name who told option A should be correct?
Sir, I
Rohit?
think yes, sir.
Yeah, Rohit. So I want you to tell me that answer when I discuss this 3 concept, and we'll come back to that question. Okay. So now see that I have already written a definition here just to minimize, we can optimize our time here. So now you see this symmetric relation, first what it is. Now let R be a relation in set A, then R is called a symmetric relation if A comma B belongs to R, then B comma A should belongs to R. Now this is the thing, right? So now let's discuss some examples here. So this is just an examples which I'll be discussing here. So even if you don't understand the definition, you make sure that you understand the examples which I say. Okay. So now have let's call set maybe 10. Let's use this another letter 7, 8, 9. Okay. And now I have my relations. Maybe I can just Ri, I can say something which is basically a subset of A cross A. Now I'll list all this Ri and you have to tell me whether this is, maybe I can say this as R1, and I'll list those elements and you have to tell me whether this is a symmetric relation or not. Okay, is R1 a symmetric relation? Put it in the chat.
No, sir.
No. Okay. Why? Because you see, what is the definition for this? If A comma B belongs to R, then B comma A should belongs to R, right? This is what it means, right? So now I can happily say that yes, this is not a symmetric relation. What about R2? Now, if I have this 7 comma 8 and now I have 8 comma 7.
Yes, it is.
Yes, sir.
Yes, sir.
Is, right? Now what about this? Now I have this 7 comma 8. I have this 8 comma 7.
Yes.
Just a minute. Now I have this 8 comma 9. Is this a symmetric relation?
No, sir.
No, sir.
No. So from here, what you can take in that all the pairs should be symmetric. Can I say that? Yes.
Yes.
I can go with this understanding from this examples that this is what I can take from this example. What can I take from this? That all the elements should be, whichever elements are there in that relation, they must be what? Symmetric for it to be a symmetric relation, right? I hope this is okay. Now let's go with another example. R4. Now I have this element 7 comma 7. Is this a symmetric relation?
Yes,
Yes,
sir.
Yes, sir. Yes, sir.
No, no.
Yes, yes, yes. This is.
Yes, sir.
Yes.
Why? It's just because you see.
Seven.
Because 7 and 7 both.
If this is A comma B,
Then B
you
comma
check, then B comma A is
A is also same.
same element. So this is a symmetric relation. Okay. So now I think this is okay. I think you can understand now. What about this? Just one more example and we can wind this up. So I have another example. Let's say 7 comma 4. Is this relation or
No, it is not a relation.
No, sir.
No,
maybe
sir.
I should not be using this because I am telling this Ri is a subset of this, but I'm violating that condition here. So maybe I should not give that example here. But all you have to make sure that relation is actually a subset of A cross A. Okay. If we play around with some other elements and then we ask you, is this, a symmetric relation, then you should be in that conscious manner that you should first see that this is from that set A, right? Okay. So now let's take another example. 7 comma 7, 8 comma 8, and let's take another example as 9 comma 9. Okay, so is this a symmetric relation?
Yes, sir.
Yes, sir.
It is or not?
Yes, it is. Yes, sir. It is symmetric.
Yes, it is.
Yes, sir.
So now we understood that. From here, I think we have exploited all parts of it. Now you see this from here, I can understand two things. Here it says what? If A comma B belongs to R, then B comma A should belongs to R, right?
Yes.
In the earlier example, when I just wrote 7 comma 7, I can even write again 7 comma 7, right? But this is a set, and the duplicates are not allowed, or even if you write a duplicates, basically in the same thing, right? So that's
Sir,
how,
what is R5?
what is
R5? Yeah, in the example section.
Okay, R5 is 7 comma 7, 8 comma 8, and 9 comma 9. So this is a symmetric relation.
Thanks.
Okay.
And sir, identity relation as well, huh?
I can come to that. I'll come to that. Maybe once we are done with all this.
Sir,
then
once again, sir, R1 is why not sir symmetric?
Sir. Sir.
Yes.
Sir, you write AB belongs to R. Sir, just scroll up. Sir, scroll up. Sir, you write AB belongs to R. Then BA belongs to R. Sir, for all elements.
No, not for all elements. That's what you can notice from here. 7 comma 8 is not elements. It's just a single element, isn't it? It's not for all elements. I'm nowhere telling you.
Why R3 is not a symmetric relation?
Why 3 is not a symmetric relation? Because you see here, this and this is symmetric. I mean, this pair forms a symmetric. But what about the other pair for this one? 8 comma 9. Do you have 9 comma 8 in this relation? You don't have it, right? Therefore, it's not a symmetric. Okay, now let's go with the other thing. I think symmetric part.
Sir.
Okay, I'll mute all first. So usually what happens is we tend to not mute ourselves after unmuting. That's why I'll have to do that always. So yes, tell me. Do you have any doubt in this symmetric relation?
Sir.
Tell me. Go ahead.
Sir, what are the minimum elements required for a relation to be symmetric?
You can have a null set as well, but I'll not go into null set.
So it was a question from practice set, I
I
think.
know what it is. Basically, they would have given you that. So it's essentially, it doesn't. We are not dealing with the null set, so it's okay. I mean, it's not about what is a minimum number of this, but it's more like what is the minimum number of elements required for it to be an equivalence relation or a symmetric relation. So, but we also tell you that there are 3-4 relations coming in there. Okay, so don't worry about it. You will be able to answer those kind of questions and will not take you to the null set here and will not deal much about it here. Okay, so but definitely you will be able to answer when I'll tell you like what is the minimum number of elements required for R for it to be symmetric, or I can say transitive, or I can say simply for it to be an equivalence relation, right? So at that point of time you should be able to answer. So don't worry about this, we'll go there. Okay, so I hope you understood what is symmetric relation for now. Let's switch on to what is asymmetric relations. Okay, so now asymmetric relation says that, now look at this example. Okay, just give me a thing. So now we understood that this part is understood. This is something we done and this is something we understood. Now here, let R be a relation in set A, then R is called as asymmetric relation. If A comma B belongs to R, then it says what? B comma A should not belongs to R. What does it says? B comma A should not belongs to R, right? So now let's quickly deal with some examples here and let's convince ourselves like what does it actually mean, right? So I can just take again same, I can take this set A 7, 8, 9 and I can say that so 7, 8, 9 and then let's say this Ri is a subset of A cross B, A cross A. Now I have to say this same examples. Let me take the same examples. Now I have this 7, 8. Okay, is this a asymmetric relation?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes. Why? Because it says
Because
what?
B
If
comma A does
belongs
not
to
belong.
R, then B comma A should not. Yeah, because it does not belong to R. So that's why we can say that this is what? An asymmetric relation. Now let's quickly take this. Okay, I'll not list now, but you know what is R2, right? Is R2 a symmetric relation? Now you have this R2, you can just see from the previous.
No, sir.
No.
No, sir.
No, sir. No, sir.
What about R3?
So R3 is not
No.
also not.
Right?
No, sir.
No, sir.
R3, R4?
Yes,
No,
sir.
sir. No, sir.
No, sir.
What about R5?
No.
No, sir.
No, sir.
No.
No or yes?
Huh? No, sir.
No.
No.
Okay.
Sir, no.
So what we have to understand
Sir, what
now,
about R3?
yeah, that's the interesting thing, and that's why I'll highlight it here. What about this R3? Let's understand this. Okay.
It is
So now you see this.
asymmetric.
What is R3? Yeah. So why is this R3 not asymmetric? Could you tell me?
Sir, because we have one.
7 belongs to R.
Okay, so one person, just one person. So maybe
Sir, 7, 8 belongs to R3.
Please go.
But 8, 7 is also belong to R3. But
9
Yes.
it is not belongs to R.
So you see this, I'll tell you. See, now let me complete now. So now you see this symmetric relation. We have to make sure that every pair was symmetric, right? We have to make sure that every pair should be symmetric, like whichever pair was present in that relation, right? Similarly, when you come for this R3, when you are looking for asymmetric relation, you have to make sure that every pair is not it is satisfying the condition for this. So if I have this A comma B, I have to make sure that B comma A is not there. If it is there, then it violates the condition, and it is that relation as a whole is not a asymmetric relation. Understood? So
I
you see this
guess
R3.
it's anti-symmetric.
Oh wait, don't go there that fast. I will come to that, and then you will understand whether it is or not. Okay. So now you look at this. Now you look at this part 7, 8. Then I have to make sure that B 8, 7 is not present in this relation, right? Right?
Yes, sir.
Because that was present, that is why R3 is no more a asymmetric relation. So can I generalize this? Can I generalize and say that that the opposite of symmetric is asymmetric? Can I generalize that?
Yes, we can
Yeah.
accept.
No,
Yes,
we
sir.
cannot.
Yes.
No, we cannot.
No, sir. No, sir.
Look at R3, it's violating. R3 is not a symmetric. If it is not a symmetric, can I say that it is asymmetric?
No.
No,
So
sir.
it is
No, we
violating
cannot
both.
say
So
that.
I cannot say that, right?
No, sir.
So you have
No,
to pay
sir.
attention for that part. Okay.
Yeah.
Now let's go to anti-symmetric relation.
But in R3, 8,7 is present, huh?
But I just explained you, right? Even a single pair violates the definition, then it's gone. It's no more it's no more a asymmetric relation.
Sir, as you said.
Understood?
Sir, as you said.
Yeah, Sumit.
If it is not an if it is not a symmetric relation, it is not compulsory that it has to be an asymmetric relation.
Right.
But if it is a symmetric relation, it is compulsory that it cannot be an asymmetric relation.
Come again.
You said that if
yeah,
a
you can
relation,
say the vice versa.
Yeah.
If it is an asymmetric relation, then compulsorily it is not an
symmetric relation.
Symmetric relation. That is something you can say.
But sir, but in case of R3, there is one element which is supporting to the asymmetric.
That's what I was telling you. See what happens is, like, even if a single pair which is violating the condition, see, if you want to disprove something, a single point will a single condition will disprove it, right?
The problem with R3 is that we agree that it is asymmetric relation according to your definition. But a single set is there which is disagreeing with the definition. So we can say na ki symmetric relation is opposite to asymmetric and asymmetric is opposite to symmetric.
That's what I am saying. One element is supporting.
But again, you
the
have to
definition.
put some condition. No, I cannot just say it on a general. I have to put some condition and say that. Right? But I cannot say anything on general without any conditions. I can put condition and make that thing right. Yeah, that is definitely right. But for that, I have to give the condition. So maybe I can just discuss one more example here and just tell me this. I have this R6 and I have element, let's say 7, 8, and now I have this 8, 9. Is this asymmetric relation?
Yes.
Yes.
Yes, sir.
It is an asymmetric.
So I think this one part was missing, so I just discussed that here. So we'll come to this more. Now let's go with this anti-symmetric. Yes.
Sir, I have a doubt, sir.
Quickly, please, quickly.
Sir, in symmetric, R1 is true, sir, but in symmetric, R1 is failed. But asymmetric, R1 is true. Why, sir?
R1 is true, right? It's just because of this definition. Look at this definition. If A comma B belongs to R, then B comma A should not belongs to R. Do I have 8, 7? That's why. Just stick on to definition. Okay. If you're sticking on to definition, the things will be easy. Okay. Okay. So now let's go with this anti-symmetric relation. It's kind of difficult to understand. That's why I've written these 3 conditions so that we will not have a confusion. So same thing again. So what you should just understand from here that I'm repeating these same elements. Okay. So I'll mute all and then I'll just discuss this. Okay. So now you say this. I have set A and then I have this relation, right? And now I have to discuss with you that I'll be having the same set again and that same relation, and we can just discuss this 7, 8, 9 and our Ri is a subset of A+. Okay. So now let's say this. First, let's go with the definition and just have some understanding of this. Even if you don't understand, that's okay. It says what? If A comma B belongs to R, and when and conditions pops in, you have to make sure that this is happening. Okay. So if A comma B belongs to R and B comma A belongs to R, then A must be equals to B. Okay. So this is one part of it. Okay. Now another thing, if R containing a single element, then it is an asymmetric relation. AR represent asymmetric relation. If R contains a single element, then by default it is an anti-symmetric relation. I'll discuss you why. Okay. Now third condition is if R containing a multiple elements, but any pair is not fulfilling condition 1. Okay, it is still an anti-symmetric relation. So now I know it's too much, but I'll be discussing some examples and you will understand. Okay. So now let's take one example and maybe I can take the same. You can mute all again.
Sir, can you mute?
Okay. So now let me take some examples and this time I'll take some different examples. So maybe I can just take this R1 and I'll just tell you that maybe I can just take one example and then we can have some controversy talks here. Yeah. Because this is something we can have some controversial talks. So we can have this R1, and it says what? This R1 contains element 1, 2 and 2, 1. Okay. So is this an anti-symmetric relation?
No, no.
Yes, sir. No, sir.
No, it is not. But why?
No.
But why? Let's understand this. Now look at this.
Because A cross A does not contain.
Just a minute, just a minute. Here it says what? If A comma B belongs to R. So A comma B belongs to R, yeah, okay, fine. And B comma A. So I have this, if this is A is what? 1. What is B? B is 2, right? So if A comma B belongs to R, yes, it does belongs. And here this and condition is being fulfilled. So this is true. And if this is true, then this must happen. That is, A should be equals to B. Okay. So is my and condition being fulfilled in this R1? Now, if this is what?
Yes, sir.
B comma A, right? So now you see this, I have A comma B. This is true. The first part is true. And condition comes in, okay, that is also being true. And even this is true. If these two are true, then A should be equals to B. This is what it says. If A, so is A equal to B here?
No.
A is not equals to B,
No, it's
right?
not.
So the and condition, both of them were true. So this is true and this is true. If both were true, then it must have what? A should be equals to B for it to be what? Anti-symmetric. So therefore, this is false.
Sir,
Now you will have doubt.
sir,
I
here-
know. Just a minute. Just a minute. I'll tell you. I'll just tell you in the beginning. Let me complete all examples. Then I can take up your doubt. Okay. Because
Sir,
I know
here
what
capital A.
Just a minute. Just a minute. Just a minute. I'll just finish first some 5-6 examples, and I know what doubts you have. So once I discussed all those examples, all your doubt will not be there. It's just the clarifications what you will be doing. So let me just complete those examples, okay? And then I'll take up the doubts. Otherwise, we'll just land up nowhere and we'll not be able to complete what we have promised to do, right? So let's take another example. Now let's do this. Okay, so here I made a mistake. It should be basically 7, 8, and let's say this is 8, 7. I should have not used that. This is B comma. All right. So now let's take R2, and in R2, what am I doing is I'll take one example. This is 7, 7. Okay. So is this an anti-symmetric relation? The answer for this is
Yes, sir.
Yes, sir.
Why?
Yes, sir.
Why? Because you see this.
It contains a single element.
Okay, no, that is definitely right. But how did we come to this part? Is
A
because
is
of
equal
this
to
first
B.
definition.
A is equal to
You see
B.
this?
Both elements are same.
Okay, let me talk. Okay, so when I'm explaining, all of you can keep silent. But when I ask, you can give me the replies. Okay. So now you see this: A comma B belongs to R. Is A comma B belonging to R? Yes. Is my AND condition being fulfilled? Yes, even that is being fulfilled. Why? Because you see this is B comma A as well, right? Right. So this is A comma B, and the same element is B comma A, isn't it? So if this AND condition is being fulfilled, then what I have to make sure A should be equals to B, right? Is A equals to B? The answer is yes. And if it is yes, then what? This is an anti-symmetric relation. That is why the second condition popped in here. Just to avoid any kind of confusion, or if you have it, just remove it. So it says what? R containing a single element is asymmetric relations. But again, you might have some doubts, and I'll clarify that doubt as well. Now let's go with R3, and in this R3 I have element 7, 8. Okay, so now you see this 7, 8. Now look at this part. Let's go with the first definition. A comma B belongs to R. Okay, fine. This is true. True for R3. Do I have B comma A in this? The answer is no. So this statement becomes false, right? So this statement becomes false because this is true, this is false. I'm not entering into this condition. I'll go with the second one. R containing a single element is what? An anti-symmetric relation. It contains a single element. Yes. So this is what? An anti-symmetric relation. So in other words, even without knowing these two definitions, you can actually tell the answer. So whenever this first statement becomes false, right? Whenever this first definition becomes false, then you can say that, yeah, there is a chance for it, if it is a single element, for it to be a right? So it becomes an anti-symmetric relation. So then and there, right? So this is an anti-symmetric relation. And I know you still have doubts. I'll take up those doubts. So let me go with another example. Look at this R4.
Can you explain So can you
I'll do all that, but let me complete all examples. Now look at this part. Now I have this element 7, 8, and then I have, let's say 8, 9. Okay. So now you see this. This is what, now again, my second condition will definitely not fall in. Now look at the first condition here, because here second definition says what? It should contain a single element for it to be a anti-symmetric relation. But now look at R4. R4 second condition does not fulfill. So now I'll first check with the first and third. If A comma B belongs to R, okay, A comma B belongs to R. So first part is true, and B comma A belongs to R. So do I have B comma A here? If this is A comma B, do I have B comma A here? Okay, this is B, but this is not A, right? So this is B comma C. So certainly the second statement is being false here, right? So now when it becomes false, I move to the second definition and third definitions. So when the first definition falls off, now this is not satisfying. So what I'll check with the second. Does it contain a single element?
No.
Then I'll go with the third conditions. Now third condition says what? R containing multiple element, but any pair not fulfilling condition 1 is asymmetric relation.
Yes.
Now what do we mean by this?
Condition 3 is true.
R containing condition 3 is true, and therefore this becomes right. Okay. So now you see this. Essentially, you can derive this from the first statement itself. Whenever this becomes false, now you see first elements. You can just take the first element. This, if I just had this element 7, 8. If I just had the 7, 8, then this was anti-symmetric, perfectly fine. Now I'll check with this. If I have A comma B, do I have B comma C, B comma A with this pair? I do not have. So again, with the same condition, since my AND condition is not being fulfilled, then I can happily say that yes, this is an anti-symmetric relation. Okay. Now this is my R4.
So can you explain the third point again? R containing multiple elements.
Okay. So R containing multiple elements, but any pair not fulfilling the condition 1. Okay. So now you see this. Now if I have this, let's take this first pair. So now if I'm taking this pair, so you see this A comma B belongs to R, right? And so do my AND condition fulfill here? The AND condition do not fulfill here, right? So if it does not fulfill here, so then I can say that, okay, this is an anti-symmetric relation. So this fulfills that conditions. Now let's go to this part. If this is A comma B, do I have this AND condition being fulfilled for this element? Again, this is not being fulfilled. So I can still say this is an anti-symmetric. Since all the elements are being anti-symmetric, so as a whole, R4 is anti-symmetric. Okay. So I'll take up doubt again. Now let me go with one more example. R5, and now in this I have this element 7, 7. I have 8, 8, and I have 9, 9, and then I have 8, 9. Is this an anti-symmetric relation? So the answer is
yes, sir. Yes, sir.
Yes, it is.
So could you 8, 9 how?
Yeah,
no, sir. So why?
Because one pair is not fulfilling condition.
Yes, sir.
So even here also, R containing multiple elements, but any pair not fulfilling condition 1 is asymmetric. Now you see this.
Okay.
Okay, sir.
3 are fulfilling now, sir.
This one. Look at this element. Look at this element. Does this fulfill the criteria of the first condition?
Yes.
Yes.
This also fulfill the first condition criteria. This also fulfill the first condition criteria. Look
Yes,
at this part.
But last one, so last pair.
Last one. Look, go with the first definition. Go with the first definition. First definition says what? If A comma B belongs to R, and do I have AND element for this? Do I have 9, 8 for this? I do not.
No, sir.
No, sir.
I'm not entering into that definition at all, right? So I can by default say that yes, this element is also an anti-symmetric.
Yeah.
So this also is an anti-symmetric. So that's how I get it. Now, one by one, I'll take up the doubt for this. Yes.
Sir, can we say that
one person, maybe,
R3 seems to be asymmetric.
Okay. Aditya, I'll take up your doubt. So R3 seems to be what? Asymmetric.
Asymmetric, yes.
Okay, now let's just discuss anti-symmetric, then we'll go to asymmetric. Of course, it is asymmetric. But First, do you have any doubt here now?
Sir, R4, sir, it satisfy third condition. Then R1 also satisfy the third condition. Then why it is not anti-symmetric?
Okay, R containing multiple elements, but any pair not fulfilling condition 1. Okay, but any R containing multiple
According to
elements,
the third definition, it satisfies.
Yes, sir. According to the third definition, it satisfies the condition. Then it should also be anti-symmetric.
No, it's actually not, because you see, but any pair not fulfilling condition 1. What is the condition 1? The AND condition 1 is being fulfilled here.
But sir, the first condition also says that in spite of the A and B need to be equal, right?
Okay, so you mean to say that is partially right? That's
yes, sir.
Yeah, it's partially correct, but it's still it doesn't fulfill the condition, right?
Yeah, get it. So maybe what I can do here is this can be
R1 is also
I can just remove this. I will not take this third condition, and I'll just keep this 2 conditions only. Okay, that was just simply I just kept it for
Sir,
so that
I have doubt in R1.
We will not enter the third condition, and I'll tell you with these things itself. Okay, now I'll just repeat this and then you can tell me out. Now look at this first definition. R1, if A comma B belongs to R and B comma A belongs to R, then A should be equals to B. So you see this, first of all, if this and what you do is you check for every element in your relations. Okay, so now you go with this. If this is true, then you go with this. And if even this becomes true, then you'll have to make sure that this is happening for it to be anti-symmetric.
Sir, and represent that both should be true. A should be element of R and B should be element of R. Right.
Right. So and
so in spite of then, you mean to say that there should be an end.
Could you come again?
In the first condition, if A is equal to B and belongs to R, and B comma A belongs to R, and A equals to B, is it the condition?
No, and not. It's then you say that A should be equals to B, or you can just, for your understanding, you can say that and this should be equals to B. Yeah, that is up to you, like how you understand it. But what it means is that A should be equals to B in that case. Now let's go with R2. Let's go with R2. R2 is again, you see, so R2 by default you can use the second condition, right? R containing single element is anti-symmetric. Simple, right? But if you want to understand this with the first definition, what you do is you can just see this. If A comma B belongs to R, so you see AND condition will fulfill here. This is true, and B comma A also belongs to R. So this is also true. Then is A equals to B? The answer is yes. So therefore R2 is correct, right? Now come to third one. Third one, what you say is when A comma B belongs to R, and you don't have AND condition here. So when you don't have this AND condition, the other thing is not at all there, then what do you do then? You enter the second definition. Okay, is it okay?
Yeah. In the 7,8 set called 7,8, we called it was asymmetric because A comma B should belong to R, then B comma A should also belong to R, but there was no B comma A.
Yeah, no. If there is B comma A, then you have to make sure that that is happening. But there was, since this was being false, right? After and there was no second condition being false, so this becomes false. So you enter the second definition. Now let's quickly look at this R.
7,8 is also asymmetric and anti-symmetric.
Okay, we'll come to that part, but let's just stick on to first anti-symmetric. So now is how R4 was being anti-symmetric. So what you do is when you have more number of elements, we don't have that third condition. When you have more number of elements, you individually check for it. Okay. So what you do is you check for each and every element. Now look at 7,8. Do I have 8,7 in this?
No, otherwise it should be symmetric.
Yeah. So now you see that R4, when I'm dealing with R4, I have 7,8. Do I have 8,7? My AND condition is not being fulfilled. So I can say that, yeah, second condition will apply for the first element. Okay, for this element, I can apply the second condition and say that, yes, this is anti-symmetric. Now look at this part. If 8,9 belongs if 8, 9 belongs to R, yes, it does. Do I have 9, 8? I don't have 9, 8.
It violates
So
first.
since this again, it violates the first condition, and therefore I enter the second, and then I say that yes, this is an anti-symmetric as well. So now I check for all elements, and all elements are being anti-symmetric. Therefore, R4 as a whole is being anti-symmetric. Now look at R5. R5 is again 7, 7. 7, 7, you know that first condition itself will apply, and it is true, right? So 7, 7 is an anti-symmetric relation. Yes, that is right. 8, 8 is an anti-symmetric relation. Yes, that is again right. Because what you can apply the first condition here, and 9, 9 is again an anti-symmetric relation because you can apply the same condition, right? The first condition. Look at the fourth one, the fourth element, that is 8, 9. Do I have 9, 8?
No.
I have it. So
Again,
I'm not entering the
anti-symmetric.
first condition, and then I enter the second condition, and I say that yes, this is an anti-symmetric relation because I don't have 9, 8. Right? Right?
Yes.
What if I had 9, 8? Will that be an anti-symmetric relation?
Yes, sir.
No, it won't be in that case.
So can you explain it, sir?
Okay, so I'll do that here. So maybe I can just write it down here, and then I say that I have R6, and then I say this. I have 7, 7. I have 8, 8, and I have this 9, 9, and then I have 8, 9, and then I have 9, 8. Now this is my relation, and now I have all these elements. Is this an anti-symmetric relation?
Sir?
No, sir.
No, sir.
Anti-symmetric relation, because we know that this element is anti-symmetric. Yes, no doubt. Is this an anti-symmetric? Yes, no doubt. Is this an anti-symmetric? Yes, no doubt. Now you look at this. Now I'll mute all. So now what? Now look at this part. Now I have this 8, 9. So now I'll look at the first condition. What is that first condition say? If I have 8, 9 and B, 8, do I have 9, 8? And I happen to see yes, there is. So if that is the case, then is A equal to B? Is A equal to B here?
No, sir.
No.
So it is not, therefore it is not, right? And therefore, as a whole, this is not an anti-symmetric. Clear? So even if one violates, it is not an anti-symmetric. So now this is okay. Now come to this part. Now all of you put your answers in the chat window and tell me what is the answer. Put it in the chat window. What is the answer for the first question? My God, still you say 3. I thought you would have understood.
Sir, R equals to rat.
Yeah.
Cat, dog, cat, rat, dog. So above, none of the above. 4.
Oh, great.
None of the use, sir.
At least.
4, sir. No.
At least I can understand that, you know. Now this is herd thing. It's like a herd. Like since everybody is saying 4, so let's say 4. So I think at least like 30% of you would have understood, not more than that. Okay, so even if you didn't understood, just go rewatch this video, okay, and go through the content that I've been sharing you here. So now let's see again, let's discuss this, why it is not. Now look at this part, and I'll try to explain you this. And let's see what is the correct answer for this. Maybe I don't want to be biased here, so let's see first how is this happening. Now look at this. This says our set A, and it contains rat, cat, dog, right? And what is our relation? I'll mute all. So, and then I have relation R, which contains rat, rat, cat, dog, cat, and rat, dog. Now, what am I doing? I'm checking for symmetric relation. So, is this element symmetric? We'll go element by element. Okay, is this element symmetric?
No, sir.
Yes, it is.
Yes, sir.
Oh,
I'm
this
talking
element
about
is
this
symmetric. Yeah, element is symmetric.
I'll mute all again. So rat, rat, this element is symmetric. Okay. Why? Because this is the pair in itself, right? When you talk about symmetric, you look for a pair, isn't it? Rat, rat, then what is the other counterpart pair of it? The same thing, right? Now, if I have this rat, rat, now this element is symmetric in itself. Now look at this element, cat, dog. Now do I have dog, cat?
Yes, sir.
This forms a pair. So
Yes.
this element is symmetric.
Yes, sir.
Look at this image. Now look at this element, dog, cat. So when you unmute yourself, unmute it by yourself. I mean, mute by yourself. No? When you unmute, try to mute by yourself, okay, after talking. So now you say this cat comma dog. So do I have dog comma cat? Yes, I had it here.
Yes, sir.
So yes, this is an symmetric. Now look at this part. Now if I have dog comma cat, do I have cat comma dog? Yes, I have.
Yes, yes.
This is also what? Symmetric, because this will pair with this. Essentially, this was pairing with this, right? And this in itself was pairing with. Now rat comma dog. Do I have dog comma rat in this?
No.
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 None
So
of the
this is not
above.
No, sir.
No, sir.
So is this a symmetric? The answer is no.
No.
Okay. How can you directly go and say this is none of the above? Let's go in the order. Let's see that. Okay, so now let's understand the other part of this. Now let's understand this. Now, is this an asymmetric relation? Asymmetric says what? If A comma B belongs to R, then B comma A should not belongs to R. Right?
Yes,
Now
sir.
look at this. This is A comma B. Is the same element B comma A? Yes.
No.
Yes, sir.
Yes.
Yes, sir.
Yes,
This
sir.
element is asymmetric. Asymmetric.
No.
No,
No,
it's
sir.
violate.
No,
No,
sir.
sir. It
It
violates.
violates.
the
So
condition.
if single violates, it's done. Otherwise, if you want to check over here also, you can check this. Cat comma dog, then I must not have dog comma cat. Do I have dog comma cat? Yes, I have.
Yes.
Yes, sir.
This
Yes.
also violates. This also violates. This does not violate, but it doesn't matter. Even if single violates it, it's not, right? So second option is what? Gone. This is not an asymmetric relation. Now look at anti-symmetric. Now this is important. And this is important from your quiz point of view as well, okay? Because these kind of questions will be asked for sure. So you better learn it in a thorough manner, okay? So now let's go with the other thing, anti-symmetric relation, okay? Now look at this. You know, it's a same element, right? This is A comma B. What does anti-symmetric says? If A comma B belongs to R,
Then
and
B comma
B comma A belongs to
A should also
R,
belong to R.
belongs
then
to
I
R,
must make sure
and
that
A is equal to B.
Yeah. So now A comma B belongs to R. Okay, fine. This is true.
B comma A belongs to R.
B comma A belongs to R. This is the same thing, same element again. So this is also
And
true.
A is equal to B.
Then A is A equal to B? Yes, the answer is
Yes.
So this element is anti-symmetric. What about
Anti-symmetric.
this?
Yes, sir.
What about this? If I have cat comma dog, so this is
Dog
true.
comma cat.
Do I have dog
A
comma
is
cat
not
in this
equal to B.
relation?
But dog not equal to
But
cat.
dog is not equal to
Yeah.
But dog is not equal to
Cat is not
therefore-
equal to dog, sir.
Yeah. So this is wrong. What about this? Dog
Same.
comma cat. So do I have cat comma dog in this relation?
Yes,
No,
sir.
sir.
I have cat comma dog.
But
But
they
both
are
are
not.
being true. But are they equal?
They are not.
No.
No,
So
they're
again,
not.
this is
No,
not.
sir.
No,
Not
sir.
This is not. Again, so see, even if single violates the condition, then by default it is not, right? So you could see here itself, this itself is anti-symmetric. Okay, let's look at the fourth condition. Rat comma dog. Do I have dog comma rat?
No, sir.
No.
I don't have it.
No, sir.
Then since I'm not entering the second part, the second
Then it
and
is
is being false, then this is, then I can say that by second condition I can say that yes, this is
Anti-symmetric.
anti-symmetric. But you see that even if one element is not an anti-symmetric, then by itself this whole R is not anti-symmetric. Therefore, I can still say this R4. The R the option 3 is again incorrect. I can say that. Okay, so I can say this that R3 is not.
It is also
Can I
wrong.
say this?
Fourth is right.
Okay, so now let's go on to the next topic, and that is this. And I want to quickly finish now because we just have 15 more minutes, and I think I have to discuss some of the activity questions as well. So we can just discuss that part, and we can end our session.
Sir, functions also.
Functions will not do today. We'll do it in the next session. Okay.
Okay.
Now
Sir.
look at this question 2. Consider a set A. Now you have in your set Dhoni 6 bat. Okay, and you have a relation R which contains just a single element Dhoni comma Dhoni, where R is a subset of A cross. Now you have to choose the correct options from this, and you have been given 5 options, and I want you to quickly answer this. And it's just that I did not teach you, but I know that you have learned from the lecture videos, and I want you to give me the answer to this.
Sir, I had confusion in these things.
That's why I
Transitive,
brought
sir.
this topic.
Option 3 is the answer.
Give me the answers in the chat window and do not talk.
Okay.
Most of you are telling 1. reflexive, identity, transitive, equivalence. Is anybody telling 4? Divyanshu, Abhishek. Okay. Then 4 is not a right option. How is anybody telling 4? No, nobody is telling 4. Okay. R is equivalence relation? No. So at least I give you an answer. Okay, 5. It's okay. So it's not always that none of the above is correct. So I can even say that 5 is also not right. So what? Now let me say still. Okay, now you are left with just 1, 2, 3. Okay, great. So I can see like some of you have given, I mean, I see some random answers like 1, 2, and 3, 1, 2, and 1, 2 not, and whatnot. Okay, so let's see this, which among them is correct. Now we can just discuss this, but not convinced that all of you know this, what is reflexive, identity, and transitive. So let's discuss that. And once we discuss, and then let's attempt it, right? Let's attempt this one. All right, so now what do you mean by reflexive relations, right? So now again, that same story where, you know, a relation R is a subset of A cross A. I have not written that. It's just that if A comma A belongs to R for all A belongings to A, then it is a reflexive relation. So I would advise you to do not go with this actual definition with mathematics, but pay attention to this part, the one which is been written here in the star mark. Because this mathematical definitions, it's kind of hard to understand, and I feel it's incomplete also in some sense. No, it's actually not. I mean, this is something Prof has also discussed it. So just for that sake, I have written it here. But I want you to pay attention to this star mark, what I have written here. So you see this, before coming to this part, I want to discuss some a terminology called diagonal element. So it's just a simple thing. Now, if let's say if I have a set A and it contains element 1, 2, 3, okay, or maybe just element A comma B, or maybe, yeah, A comma B. And if I'm doing this A cross A, so what do I mean by diagonal element is, now I'll just draw a matrix here, and I'm drawing a matrix element of this. So if this is A, this is B, and this is A, and this is B. So I'm just writing this as A comma A, and this is going to be A comma B. This is again B comma A, and this is going to be B comma B, right? So I call these elements, now look at this, these are identical elements. Can you see this? A, B, B, and if I had this C also,
Yes,
then
sir.
would have got CC. So these elements is something I'm calling as a diagonal elements. Now I hope you understand this, right? This is something I'm calling as a diagonal elements, and you see these diagonal elements are identical in itself, isn't it? You notice that?
Yep.
Yeah.
So that is the word which I'll be using here for the explanation. So now you see this, whenever we talk about reflexive relation, it says what? Must contain all diagonal elements. Okay. And other elements can also be present. That is also right. Okay. So now let's discuss some elements. I'm not going with this mathematical definition, but I want you to stick on to the star mark definitions. It must contain all diagonal elements. So you see this, it's all, okay. And the other condition is other elements can also be present. Okay. So now if I have to say this in another nicer way and list some set here. So if I have the set A 1, 2, 3, and if I have this relation R, okay, and you know the normal way, R is a subset of A cross A. So please make a habit of unmuting yourself. I mean, muting yourself if you unmute. So this is something I got it. So now let's say if I have this R1, let's say this R1. So maybe I can just use this notation. Yeah. Let's say if I have this R1 and I have this element, let's say 1, 1. Okay. So is this an reflexive relation?
Yes.
No. Why it is not?
Because it contains it's only one element.
It
Must
contains only
contain
one
all diagonal
Not all
elements.
the diagonal elements are present.
Right. So I must have this. Is this this relation? Is R2 a
Yes, sir.
reflexive?
Yes, it is.
Yes, sir.
It
Now
is.
look at this for this R3.
Sir, just sorry to interrupt. Why R1 is not reflexive?
It's just because you must have all diagonal elements.
Okay, sir.
Here's the
Thank you.
definition. Yeah. Now look at this 1, 1, 2, 2, 3, 3, and let's say 2 comma 3. Is this an anti-symmetric? Is this an
Yes, sir. Yes, sir.
Yes,
This
sir.
is
Yes,
it
it
is.
is.
Yes,
Why? Why?
because last sir,
So
other elements
other
can
element
Can also be
contains
present.
And also other elements.
Can also be present apart from the diagonal elements, right? So this is
Yes, it is. It is.
okay. Now tell me this. I have this R4.
means other elements from the set.
Yeah, I have just this. Is this an reflexive relation?
No, sir.
No, sir.
No.
No diagonal elements present.
sir. First,
No diagonal elements, right? So this is wrong.
first option is it is not real.
So now look at this. I have 1 comma 1. I have 2 comma 2. Then I have let's say 3 comma 3. Now maybe I know you can answer this, but let's take another example and let's say this is 2 comma 1. So is this?
No.
No.
I think
So, sir, all diagonal elements must be
B is
present.
absent here.
so this 2 star mark thing is enough for you to understand this. So what did you understood from here? Reflexive relation must contain all diagonal elements and other elements can also be present.
Can also.
Now look at identity part. Identity, I'll come to this, then I'll take these take the questions from you. Now look at this. Identity relation
Ma'am,
tells what?
sir, what is reflexive relation? I got disconnected.
Okay, so the reflexive relation must contain all diagonal elements and other elements can also be present. So if you got disconnected, just watch this video again. We'll be sharing you this. I mean, you will have the link for this. Okay? You can just see that part because we don't have time right now, right? It's already going to be 9. Now you look at this part. What does this identity relation tells you? It must contain all diagonal elements only. That means, can you have other elements apart from diagonal elements?
No.
No, only diagonal.
Elements like 1, 1, 2, 2, and 3, 3.
That's all. So now, but just for simplicity, can I say this R1 is? So I'll make it. Can I say this R1 is R1 a identity relation?
No, sir.
No, sir.
Let's see from here.
No.
No. What about R2?
Yes.
Yes, sir.
Yes.
What about R3?
No, sir.
No.
No, sir.
No. What about R4?
No, sir.
No, sir.
No, sir.
R4 is not as well, right? R4 is not, right? Yeah.
Yep.
Sir, how to find diagonal element by matrix?
Diagonal elements are just this identical elements. You don't have to make and all. You can just simply identify, right? It's just the identical elements. And you must have all identical elements.
Okay, sir.
What about R5?
Just copy the set.
No, sir. No.
No, sir.
No, sir.
No, sir.
I think you understood. So can I say this reflexive relation? Sorry. Can I say this identity relation is a subset of reflexive relation?
Yes.
Yes, sir.
So that is something I can understand.
Sir, how R5 is not fulfilling the that second criteria, sir?
Because you see that you must have this element also, no? You must have 3 comma 3.
All the elements must be equal.
And it should only have diagonal elements. It should have all the diagonal elements.
The reflexive, sir. I'm talking about reflexive. How the R5 is not fulfilling that second option?
Because you don't have 3 comma 3.
2 comma 1 is there, right? So it is.
So in reflexive relations, the elements cannot be present.
It must have all diagonal elements.
Oh, this is the same elements, 2 and 1, right?
The elements cannot be present, sir, in reflexive.
Okay, let me just talk. Okay, yeah, you ask your doubt, please. You ask your doubt, please.
Sir, I was confused with
Yeah,
R5.
Vishwajit. Let me answer. Yeah, Vishwajit. Yeah, please go ahead.
Yeah, sir. Other elements can also be present. Like so, other like 2 and 1. Is it considered as the same element or this a different element?
It's a other element. Other element means apart from diagonal elements.
Yeah, so it is fulfilling that, right? The second criteria, right?
But it must have all diagonal elements. No? It is not or in between. You see, this is not or, right?
1, 1, 2, 2, sir.
But it is not all diagonal elements. No, you must have 3 comma 3 as well, right?
Oh, okay. Got it, sir.
Got it.
Yeah.
So now you see, yeah.
Just a doubt. So if our set was, if the set A was contained one pair with 1 and 2, so would the R5 option be considered a reflexive element if there was no 3 present?
Yes. You can say. Yeah. So identity relations we understood. Let's go with transitive relation, and this is something important. So pay attention to this. Okay. So now you see this. Now I know where to catch you here, because I think now you understood that anti-symmetric. So you should be able to tell this answer, and I guess most of you can answer this. Let's see how many of you can answer this. Okay. So now first I have set, let's say 1, 2, 3, and I have relation Ri, which is a subset of A cross A. Now you understand this from here. First I'll tell you what is transitive relations. Again, that same story, that R is a subset of A cross A. And if A comma B belongs to R, I'll mute you all again. It says what? If A comma B belongs to R and B comma C belongs to R, then A comma C should belongs to R. Right? Clear? So here there is again an AND condition. So whenever if it is false, then you enter the second condition, right? Okay. So when this is not happening, so now let's go with this. If A comma B belongs to R and B comma C belongs to R, then A comma C should belongs to R. So it's similar to what you have learned it in anti-symmetric relation. So now, and what does second condition says? Or if AND condition is not fulfilled, in this case too, the R is transitive. We'll see how is that happening. Okay. So now let's go with this part and discuss our first relation, that is R1. And let me list one element, let's say 1, 2, and 2, 3, and 1, 3. So is this relation a transitive?
Yes, sir.
Yes, sir.
Yes.
Why? Because I have A comma B. What is A? A is 1. What is B? B is 2. Then I have to check those elements which starts with B. So does this element starts with 2? No. So this is not that pair. Does this element starts with that?
Yes.
Yes.
Yes, sir.
So this is my B. Then naturally the second part of it becomes C. So this is B. So if this is B comma C, then do I have A comma C in my relation?
Yes.
Yes, sir.
Yes, I have. And this becomes right. Okay. So now let's go with the other condition. I mean, let's go with our R2 and understand this better, and then we can understand. Now let me just have this, just one element, and let's say I have just 1, 1. Okay. Now look at this. Is this a transitive relation?
Yes.
Yes.
Yes, but I'll tell you
Yes,
how.
sir.
If this is A comma B, then I will look for what? B comma C. So what is B? B is 1. So this element itself is B comma C, right?
Yes, sir.
So do I have A comma C in this relation?
Yes, sir. Same element.
It's the same element, and therefore I can make an understanding from here that a diagonal element is what? A diagonal element, I can say that yes, a diagonal element is always what? A
Transitive, sir.
A transitive relation. So I can just generalize that. If I take 2, 2 and 3, 3, I can still say they are what? Because of the same condition.
Yes.
Now look at this part. R3. Now you have to tell me about R3. R3, we can take this as 1, 2. Okay. So now I have this 1, 2, or maybe I can take another example also, and I can say this. I have 1, 3. Then this will make sense. Now look at this. Now I have this A comma B. Do I have B comma C here?
No, sir.
No, sir.
I do not have B comma C. So I can say that if I do not have B comma C, therefore I can say that this is what? A transitive relation. Right. Now let's go with the other one.
Sir, but here 1, 3 is a value. So how can it be?
No, I'm just talking about just this element. This element is transitive. Because I don't have B comma C, to check for the AND condition, right?
You are saying the condition is not there, so it is.
Yeah. The condition is not there, so we are not entering into the definition itself, right? So now look at this part. Now, if this is A comma B, then do I have B comma C in my relation?
No, sir.
I do not have, so I can still say that this is what?
Transitive.
So this is transitive.
All relations.
If both are transitive, then I can say that R3 is transitive. Now I'll have a peculiar.
Sir, just can you explain R3 once more, sir? I could not catch it.
Yeah, sure. So you see this, I have A comma B. Now what is the condition? It says what? Transitivity says what? If A comma B belongs to R and B comma C belongs to R. So what? AND. If there is an AND, then you enter into the definition, right? If AND is not being fulfilled, then I can still say that this is transitive. Okay. So now I'll check.
Just I'm saying, sir, when 1, 2, that is A comma B, it is belonging to R, but we don't have the B comma C there in R, then what you were saying, we are not checking the relation.
Will not get into that definition part at all, right? Because it
Okay, sir.
becomes, yeah. So therefore, I can say that this is transitive. Or you can use the second condition. If and condition is not fulfilled, in this case too,
okay,
the R is
okay, sir. Okay, sir.
That's why
Understood,
I have.
sir. Okay. Sir.
So now you notice this. Now you tell me for this one, and then we can understand this. Now I have this 1, 2. I have this 2, 3. Then I must have what? 1, 3 for it to be transitive. Now you have to understand this one more thing here. Now I have this 2, 1. Is this a transitive? Let us
No,
know
sir.
if you are
Yes,
saying.
sir. No.
Yes, sir.
No, sir. No.
No, sir.
So although
No,
you are
it's not
saying
a
no,
transitive.
then you are actually.
Yes, sir. Just 10 more minutes.
See,
It's
1 is
transitive.
not present,
It
sir.
is transitive
Yes, sir,
because
it
It
is.
is not transitive, but
No,
why?
sir.
Let's understand this.
1, 1 is not present.
Yeah. I'll tell you why it is not. Look at the first element. This is A, B, right? Then I must look for all those pair which starts with B, right? Does this starts with B? Do this starts with B? No.
No,
So
sir.
this is not forming that pair. So I'm looking for this and condition now. Do this starts with B? Yes, it starts
Yes.
with B.
It
So
starts
this
with
forms a pair. Now this is a pair, right? Now,
Yep.
do I have any other elements which starts with B? Does this starts with B? No.
No.
Do this starts with B? Yes.
Yes.
It becomes B
C.
condition. So now what? I'll be checking this condition that now.
1, 3.
So now what? If I have, now look at this pair. Now if I take these two pair, and then I check for what is my A, C present in this relation. So do I have A, C in this relation? When I take
1,
these two pairs.
3. 1,
Yes, sir.
3 is A, C.
So I have this. So I can say that yes, this is being right for this pair. But what about this pair? Because I can choose this pair as well, right? So what about this? Do I have 1, 1 in this relation?
No, sir.
No, sir. No, and therefore this is not transitive. So you will have to check for every pair. Understand this. All right?
Yes, sir.
I didn't get.
You didn't get? Okay,
Can
I'll
you
explain
explain it again?
Okay, this
again?
is, yeah, no problem. I'll explain you again. So look at this part. What am I doing here is I'm looking first. I'll check with my condition. So what does condition says? If A, B belongs to R, right? And B, C belongs to R, then what?
A, C must belongs to
R, right? So now you look at this A, B. Then I have to check for if I have or not whether this B, C. So what? I'll start with B. Does this starts with B? No. So this is not in itself a pair, right? Then I'll check with this. Is this a pair? Is these two forming a pair?
Yes.
Yes. Now I'll check with this. Is this starting with B? No, this is not starting with B. Then this is starting with B. Yes, this is starting with B. So I have two such pairs to check for, right? So now you see this. Now if I have this A, B, and if I'm just looking at this pair, for this pair it's fulfilling this and condition, right? So if this fulfills this and condition for this two pair, then I have to make sure that this third element is present in this. Do I have third element for this two pair? Do I have the third element for this two pair?
No. Yes, sir.
One person who did not
Yes,
understand. I don't know what's her name.
1, 3 is
Yeah,
an extra element. So doesn't it create problem? Like 1, 3?
No, you see, you understand this. Now you have this A, B, and then you have this B, C. Then I must have what? A, C. So if this is my pair, then I have it. What about this pair?
We don't have.
We don't have.
If a single,
this pair.
it's void, sir.
But sir, if we had the pair, then there could be a possibility that.
So if I would have given this 1, 1 into this, then this would have been a transitive relation.
Okay.
Sir, but in R3 we don't have B, C.
You don't have B, C. Yes, you don't have B, C here.
How it is right?
That's what the second condition come in. See, how did we discuss our our anti-symmetric relation? Remember? So we were saying that if you're not entering into the definition at all, the first definition, then we can assume that yes, this is, by itself is right. Because when do you go for checking transitivity, or let's say for in that matter anti-symmetric, was if that and condition was being fulfilled, then itself we were checking, right? If that and condition is not fulfilled, then by default you can say that yes, this is transitive. Understood? Or you can just take the second definition. If and condition is not fulfilled, in this case too, the relation R is symmetric. That's all. Okay, so I hope this is okay.
So one question, sir.
Can I ask about reflexive ones?
Sure. So here, do you have any doubt in this transitive?
Sir, can you hear me?
Please explain R3 once more, like
R4
you
or
explained before.
R3?
Yes, sir. Yes, sir.
So now look at this element, first element. If this is my A comma B. So you have to keep it in your mind that you have to go with an assumption. Yes, this relation is transitive. Go with an assumption. Now you check with this. If this A comma B belongs to R, right? If A comma B belongs to R, then I have to check for this. Do I have this B comma C?
No.
Yes.
Where do you have B comma C?
We don't have B comma C in R3.
Is any element starting with 2?
No.
No, sir. No, sir.
No, sir. No, sir.
No
And
condition is
therefore-
being fulfilled.
Yeah, so the and
And
condition,
condition is not being fulfilled.
Yeah, therefore I can say that this element is transitive. I can say that this element is transitive. Now look at the second one.
I have a question. Can I ask?
Sure, go ahead.
If condition AB is fulfilled, like AB is fulfilled and is not fulfilling, then we can say that it is a
You can talk about that element. You can talk about that element and say that yes, that element is transitive. You can say that about element. Okay.
Okay, got it.
Got it. Okay. Now let me take R4.
Sir,
Yeah.
sir, if we take just an example of 1, 2, and 2, 3, would it be a transitive relation?
1, 2, and 2, 3.
2, 3.
Okay. Maybe I can just write down here. First, can you tell me anything about this 1, 2, and 2, 3? It will not be, because you will not have what?
1, 3.
Yeah, you will not have 1, 3. So is this R5 a transitive relation?
Yes, sir.
Yes, sir. Yes. Neither
What about
condition
R6?
is being.
Yeah. What about R6?
Sir, yes or
No, sir.
It's not a transitive relation.
Sir, and R4, both
So it's
conditions are fulfilled. 1, 2, 2, 3, or 1, 3, and
2, 1
condition
is
fulfilled.
But 1, 1 is not there now.
Yeah, but 1, 1 is not there, right? That's why it was not. Okay, so now I think you somewhat understood, and if you have doubt, you can just watch this video again, and that will help you out there. So now what? Let's go with the equivalent. Yes.
Just one last doubt before we move on. Would you say that in transitive relations, order is important? So if we had a pair that was A comma B and then A comma C, it doesn't. The transitive relation things doesn't apply here.
Okay, see. First of all, this relation itself is a set. That is something we should understand. Order matters only to this elements inside this bracket, right?
Okay.
In this element, the order matters. But when this comma separated things, here the order does not matter. You can just write it in any manner.
Okay.
Yeah.
So
now what? Yeah.
So I didn't get the 2, 1 part
2,
in
1 part?
R4.
In R4.
Yes.
2, 1 part. Okay, now just tell me. Now look at this part. I'll just rewrite here. Now you have this 1, 2, and you have 2, 1. Okay. Is this relation a transitive relation?
No, sir.
No.
1, comma.
Yeah, Sneha, tell me.
No.
Why?
A comma B.
And B comma C.
No. Let Sneha say this. Yeah, Sneha, go ahead.
B comma 1 will be C. It's not A. 2,
No.
1.
No. When you check for this element, right? When you say this A comma B, and when you check for the other element and B comma C, right? So you check for what? This is B, right? When this is B, then the corresponding element, what it is C. Okay.
Okay.
Yeah. So the C is like this. Okay.
Okay.
So now what you should have in this for it to be now?
So 1, 1 should be
1,
there.
1 should be there, right? So do
Yeah.
I have 1, 1?
No.
That's right.
Now I got it. Thank you, sir.
Yeah. All right. So now let's go with the equivalence relation. So now you know Equivalence relations are all those relations which is reflexive, symmetric, and transitive. You see, there is an annotation. So if a relation is reflexive, symmetric, and transitive, if it is all these three, then you can say that yes, this is an equivalence relation, right? For an example, now if I have this R, maybe I'm using the same set. Okay, so I can say that the same set is one. Please mute yourself. And Ri is A cross A. And now if I take this R1 and I say this, I have just element 1, 1. Is this an equivalence relation?
No, sir.
No,
No,
sir.
sir.
Why it is not?
Yes.
Because reflexive is not present.
Yes, because this is not reflexive. Therefore, it is what? Not equivalence. Because what it should be? What it should be reflexive, symmetric, and transitive. You see, this is symmetric as well as transitive, but it is not reflexive. Any doubt on this? Anybody?
No.
Great. So now let's go with R2. 1, 1. Okay, can someone quickly tell me if this is my relation, for a relation to be equivalence relation, what is a minimum number of elements required for this R when your set is 1, 2?
Cardinality of A.
All diagonal elements, that is
All
3.
diagonal elements.
Yes, that is 3. Yeah, exactly. So 1, 1, 2, 2, and 3, 3. So if I just have this element, like this is the must condition, right? Because for it to be reflexive, it must have all diagonal elements, right? And if I have all diagonal elements, you know that all diagonal elements is what? Diagonal elements are symmetric, and diagonal elements are also transitive, right?
This will be the only inverse considered equivalence.
Yeah. So now you understood this. So now this I can say yes, this is what an equivalence.
Some minimum it should be an identity relation.
Yeah, you can say that. Now let me go with another example. Now I have this 1, 1, I have this 2, 2, I have this 3, 3, and then I have this 1, 2. Is this
no
equivalence relation? Why?
Yes, sir.
Symmetric is not there, sir.
Yes.
It is not.
No.
You don't have 2, 1.
It's not transitive.
No. It is transitive.
It is transitive.
It is not symmetric.
It is not symmetric.
Yeah.
Can you tell me why it is not transitive? Why it is transitive? Because you see, diagonal elements are transitive. We know this, right?
Yes, sir.
This is transitive. What about 1, 2? Do I have B, C
1, 1 as A and B, and 1, 2 as B and C. Then A and C is
now
also
let's go
present.
with this. If I have this A, B, then I'll have to check with B. Do I have any element starting with B? No.
Yes, sir. 2, 2.
This is. But this is B, C. So now do I have 1, 2? Sorry. Do I have 1, 2 in this relation?
Yes.
Yes. The same element itself, and therefore this is transitive, right? So understood. And
Yes.
but this is not symmetric, right?
Yes.
Okay. So now having known this, right? Now we understood what is equivalence relation. Now come back to this question. Could you tell me which is the right answer from this?
Sir.
Yes.
Sir. If a relation is like 1, 1, 2, 2, then 2, 3, will it be reflexive?
1, 2.
1, 1, 2, 2, and 2, 3.
And 2, 3. Will it be what? Reflexive.
Reflexive.
What is your set A?
The same thing. 1, 2, 3.
No, it won't be reflexive because it must have all diagonal elements.
All diagonal elements, no?
Yeah.
Okay, sir.
You must have 3, 3.
Sir, please zoom out, sir. I can't see the.
Okay. So, could you give me the answer? I can see like 33, 35 of you have.
Excuse me, sir.
Oh, it's being flooded with option 3.
Hello.
Yes.
Sir, I have just found out how is R5 transitive the set 1, 2, just 1, 2. How is that transitive?
In which one? In which one?
In the table, the transitive relation, the table. R5 is just 1, 2, I guess, and you have ticked mark it. So how is that transitive?
That's what I was explaining you. You enter the second condition. You see this? When do you say that you have A, B, but do you have B, C in this?
No, we don't have.
We don't have. So the second and condition is false here. So you do not enter that definition to prove that this is transitive, but it is transitive in itself by the second condition. You can say. Okay.
It's not started. That's why.
So now, I hope you understood. No, not convinced?
Yeah, so can you come back to that?
Can you repeat it again?
Yeah. So if we take 1, as A, B, so we have B, C, which is 1, 2, but we don't have 1.
Sir, repeat the equivalence relation, sir, once again.
The equivalence relations are those relations which are reflexive, symmetric, and transitive, which we something learned it here. Reflexive, symmetric, and transitive. So you just have to make sure that if all the three are being correct, then yes, that is equivalence relations. Over here, one question quickly, and then we can go with the activity question. And I can take a
Vicky, sir.
We're already done. Yeah.
Yeah, sir. Can reflexive can be an identity relation?
Can reflexive be an identity relation?
Yes.
You can say the vice versa.
Identity can be reflexive, but not always reflexive can be identity.
Yeah.
Sir, an equivalence relation partitions a set.
An equivalence relation partitions a set is a right. Yeah.
Sir, but how?
Yeah, I'll tell you, because that's something is not discussed here, but how is something is just because of that definition. Because you see, you do that equivalence relation, and with that equivalence relation, you actually partition a sets. Partition a sets in the sense you group the sets with that equivalence relation. So it's just a simple definition. It's just a definition of it. That's all. Okay.
Sir, will you please zoom out the screen? Actually, I just want to see the there. Yes, thank you, sir.
Okay, so if you guys want, I will share you this whatever I have written.
Sure.
Yeah.
So do we discuss equivalence set?
Equivalence set.
Sir, in R4
Equivalent class.
Sir, in transitive relation, 1, 2, then A, B, then B, C, belongs to, then A, C is 1, 3. And now one condition is not fulfilled, that is 2, 1. So I guess it is not transitive at all.
For what? For which one? For which one?
Equivalence
R4.
R3 example.
Equivalence?
R4 for transitive relation.
For transitive?
No. R4. 1, 2, 2, 3, 1, 3. Then one condition is not fulfilled, 2, 1. So it is not transitive at all.
Yeah.
Yeah.
Thanks.
Yeah. All right.
Sir,
yeah.
Do any other question?
Yeah. We'll do this. We'll take up some activity questions here. Do you have any questions for this? The first one. Do you have any doubt for this? I'll go in the order so that you cannot ask
question
again.
number 2.
So you see, what we are going to do right now is it's something we will discuss now and will not discuss again. Because in the next session, we will discuss if you have any doubt in your practice assignments, and we will discuss some concepts on functions, and we can do some set theory questions, right? That is something we can do, right? So over here, let's finish all our activity doubts if you have, let's just do that, okay? So yes, here, I don't think so anybody will have doubt, but if you have, you can still ask me. Do you have doubt here in the first question?
Hello, sir.
Yeah, please.
Sir, I have a doubt in activity number 11.
I'll go in the order. Let's go in the order. So I'll just scroll down.
Question number 3.
Okay. Whatever doubt it is, let's go in the order so that you will have this database with us. Like whenever you want to see this back again, like this video, you can go in the order and see this. Okay, where is something, and where all you need help. And you see some hints are also given in this red mark. This will not be shared with you, but if you want what I have written there in that notepad, I can share with you. So we can do that.
Thank you, sir.
Yeah. So over here, I'll keep scrolling this. If you have any doubt, I assume that you have gone through the activity questions, and if you are fine with it, then it's okay.
Sir, question number 3. What is the easiest way to find the solution?
Exactly. Does it has any procedure of doing like any formula type thing? That
No. It's nothing like that. You just have to list them. That's all. Okay. So this is also yeah.
So I had a small doubt, like if there is a set of 1, 1 and 2, 3,
So it is like following the first thing of transitive set, that 1 comma 1 is a transitive element and 2 comma 3 is following the second condition of or. So will the whole set be considered as
You check for,
transitive?
yes. You check for individual. Is this a transitive? Yes. Is this a transitive? Yes. So as a whole, this whole relation is transitive, right?
Okay, sir. Thank you, sir.
So I hope you don't have doubts. So stop me wherever you have doubt for
Sir,
this.
can you explain the second question, sir, in the last lecture 1.0?
Second question.
So fifth one.
Fifth one.
The fourth one, sir.
The fourth one, can you?
Okay, so second one you have doubt.
Yes, sir. I'm just not clear with it.
Yeah, Sriram. So suppose a class has n student. If we distribute 3 pens to each student and 4 pens will remain. So what you have to do here is you just have to divide and check. That's all. If there are 70 pens in total, what is the value of m? So what you do is you just subtract from each of them this 4, and then what you do is you see, if we distribute 3 pens to each student, then 4 pens will remain. And if there are 70 pens in total, what is the value of m? And what is the m? M is a number of class students, right? I mean,
okay, sir. Okay.
Like we can form an equation like 3m plus 4.
You can do it in all that way, but that was not the whole point. It's just that simple mathematically, or it's just a logical question. You have to think it in a logical manner and get the answer, right? So there are 70 students, there are 70 pens, and you subtract 4 from them. So you'll be, because that is what it was remaining. So you'll be left with what? 66, right? And now you say that how many you are distributing for each of them? 3 of 3, right? So it is like 66 upon 3, which gives you 22. Yes. Over here, which one? Which you had out?
4.
X mod 3 is 1. So how is that? So you basically have to check with an option, right? And you see there is an AND condition here, right? So what you do, you have to make sure that it is being fulfilled there. So now you take first option. X mod 3 will give you what? 3 8s are 24. And what will be remaining? 1. This mod tells you what? Whatever is the remainder will be written here. I hope you know that.
Yes,
You
sir.
know that?
Yes, sir.
Right? The mod says what? Whatever is the remainder will be listed here. So it's essentially what? You divide by 3 to this x, and whatever you get the remainder over here, that will be written here. Understood? So that's what it means. So x mod 3 is 1. So the remainder of x mod 3 is 1. So if I take the first option, so 25, when it is divided by 3, so 3 times 8 is nothing but 24. And what is the remainder? 1. So this is condition is satisfied. What about this? So 7 times 4 is what? So 7 times 3, 3 is what? 21. And 21, and what will be the remainder? 4. So therefore this becomes right, because this and the this 2 is being fulfilled here for this, right? For this option. Am I clear on this?
Sir, we got it.
Basically, we have to check one by one after like
one by one.
Yeah.
Yes. Over here, it's in this fifth question, it says what? Suppose the Sheetal's birthday is on the 8th of October and Karthik's birthday is on 9th of November, and P and Q are the square numbers. So it's basically the dates, right? And if Sheetal was born 10 days before Karthik, then what is the value of P minus 2Q? So what you do here is you first have to list all those square, perfect square numbers in the month. So in a month, how many days are there? 31. That's the maximum you can have, right? So 1 is a perfect number, right? Is a perfect square basically. 4 is a perfect square, 9 is a perfect square, 16 is perfect square, 25, and the next is 36. So 36 does not fall in your month dates, right? So we cannot list them. Now these are the only dates which we have to deal with, right? Because it says P and Q are perfect square, and these are the dates, right? So now what? Now we know these are the dates, and it also says that what Sheetal was born 10 days before Karthik, right? So when that can happen, right? So Sheetal's birthday, if it was on 25th, like you can try with all these dates, but when you check with 25th, then you will find that Karthik's days will be like after 30 days. So I mean after 10 days, which is nothing but 4. right? If considering that is of 31 months, right? Because you see, this is something which happening in the November, right? Qth of November, and he is with the October. So October, as you know, like it is what? How many days are there in October? 31, right? And for November, it's 30. So 31. So it's like 25 plus 10 makes it what? 4th of November. And therefore, now you got what are the dates? So 25th. So what is P? P is 25.
25.
What is Q? Q is 4. And that's how, and the rest is you have to just simply substitute in that and get the answer, right? Okay. So over here, for this particular question, you have to make the same denominator and then compare. Over here, you can just bring it in a decimal value and then compare, or you can use your calci because that is also easiest way. Of course, there is nothing like one way of doing is you make the denominator same and compare. That is something you can do, but that is not the whole point. You just have to, it's just an activity, right? It's just an easy problem, right? So that's why this is, again, third is doable. Then when you go with fourth, again, this is something like what sir is telling. It's directly taken from lecture. What I want you to know is this is again doable. Stop me where you have doubt, okay? Otherwise, I'll just keep scrolling down. So I don't think so you will have doubt here as well. Not here as well, because this is something even we discussed here. It's just the definition we are playing with. This is also doable.
Question number 2, sir.
Question number 2. Yeah. Which of the following is a subset of a set of prime numbers?
The question number 2.
Question number 2. Okay. So yeah, what doubt you have here?
Sir, why not, sir? B. Why not B, sir?
B is not a set because pi cannot be the element of set. Can we say that?
No, okay.
No, right? You understood, no?
Yeah, yes, sir. Got it.
Sir, is this activity 4?
You can just match with your question. I think the numbers are varying. It's written 1.4, but in your portal it might be 1. Oh, so it's written 1.3, but in your portal it might be 1.4. So you stick on to your question. What is your question? And I'll scroll down, and I think you might get it somewhere if you have any doubts. If you have those doubts over here. Now I'm in
Question number 4. Question number 4.
Of
previous activity. Yeah.
Question number 4. Tell me.
So in question number 4, I have the doubt that how is this false that empty set contains only one element, that is phi. The D option is correct. How?
D option is false, no? Empty set does not contain any element.
Sir, question number 5.
Number 5. Yeah, which of the following are empty sets? What is a perfect square between 45 and 49? Yeah, Vidyut. I'll mute all. So let's just finish this. Now tell me, what is your doubt here? What is your doubt? Can you tell me?
Sir,
Can I? Hello?
Oh, question number 5. Tell me what doubt you have.
Yes, why it's not C? C is set of all years having 366 days. Means there can be infinite many years.
Yeah, that's not an empty set. Yeah.
Okay, so
set
they
of
are
natural numbers which are even or odd, which is right. This is an empty set, right? Number is either an even or an odd, right?
Yes, sir. It can't be both.
Over here again, doable. It's also like you just have to solve this for a while, you will get it. Okay. Please mute yourself. Okay, if you don't have any doubt, then let me ask you. You don't have doubt in this third question?
Question number 2.
Question number 2.
It's like you guys were waiting for this. Okay. For which one? Question number 2, you have doubt? Yes.
Yes, sir.
Yes, sir.
So which of the following set comprehension defines a real number in an interval -2 to 0 union 4 to 8? So I hope you are fine with this symbol, what is being used here. This indicates that 2 is included, and this indicates that this value is not included.
Yes, sir. We are for
Zero is excluded.
And union is nothing but or. Understand this. Okay. This indicates or. Okay. So now having known this, now look at the options and just check this. So you see this -2 to 8, -2 to 8. But look at this, -2 to 8 is something we are not dealing with. What about the elements? 1, 2, 3, 4. This R covers element 1, 2, 3, 4 as well, but this interval does not cover that, right? Maybe I can just draw a number line and explain you that this is -1, sorry, -2.
So you just said that union can be represented with or?
Yes.
Sir, should I leave?
Yeah, it's done. Like if you don't have doubt here in the activity, you can leave.
Sir,
Or
I
if you are busy, I mean, if you still like, if you want to do something else, you can actually leave this, because this video is being recorded. You can say this afterwards also. So that's also fine.
Sir, I am waiting for you.
Sir, are you going to share this document?
Not this one, but the other one I'll share with you. The one which
Sir, can you explain activity question 4 in 1.3?
1.3.
Yeah,
I'll have to go back. You can just actually see this video again, because we have discussed that. Okay.
No, sir, but I have like different doubt. That's why.
Okay, you have a different doubt. So let me just finish this and then I'll go there. So which of the following set comprehension defines a real number in an interval this? So I hope you understood. Do you want me to explain this like here?
So one question, sir. Sir, you have just said that union is or.
Yeah.
Shouldn't it be and?
So you see this, it's basically or in the sense, you see, when you're actually telling this, what I meant to say was or in the sense, it's this part in aspects of this. Yeah.
Okay.
Definitely it's not, I mean, definitely when you're listing these elements, it goes with the and condition, right?
Okay, because here I wrote the answer B, in fact.
Yeah. So it's not and. When you say and here, that means compulsorily that you have to follow this. Then this will become an empty set in that case, I guess.
Okay.
Right?
Can you write the elements of the set?
So first of all, let me just don't give a notation on the number line. So if this is -2, let's say this is 0, this is 4, and this is something 8, right? So now you see this, when I use this symbol, this is included. And when I use this 4, when I use this kind of symbol, that is not included. Okay. So you see this, it contains all those elements from here to here and from here to here, right? But it does not contain any elements in between 0 to 4. Right?
Yes,
but look at this part. This is what you can have elements from 0 to 4 as well, right? So this is wrong, isn't it? And over here it says what? -2 to 0 and 4 to 8. It means what? Here, when you say and, it means intersection here, right? So do you have any intersection values? You don't have any intersection values. This is also there. What about this? -2 to 0 or 4 to 8. So this is right. What about this? -2 to 0. -2 to 0 is fine. Again, this and condition pops in here. But again, and means you have to find the intersection. So do you have any intersection region between this? You don't have it. It's just this. Okay.
Got it, sir.
Sir, intersection means and union represents or here.
Yeah, right.
Okay, thank you, sir.
Sir, I have doubt in activity number 11. I am waiting for you.
Okay. I'll go in the order and I'll just see. And somebody asked me 1.3. We'll see once we have finished this.
Sir, fifth question.
Yeah, I'll come to that. But since I'm going in an order, so let's just finish that order. Okay, so here you don't have doubts. What about this question number 5?
Yes, sir.
Sir, for third question, why we consider less than 1000 when you ask
for this one?
For the first, yeah, for the third one, we ask for the first 100 natural numbers. So I'm doubt about the C. Why we not consider the first one?
C is considered.
A answer.
C is right.
Then in C only I have the doubt. Why we consider n is less than 1000? Where in the question we have asked for the first 100 natural numbers?
No, you see this. You're listing the element. This is the set comprehension. Then you do the set builder. Okay. So now you see this. This is AND condition here, right? Now you see this set of all n where n is natural numbers, but there are another condition. Square root of n is again a natural number, right? And n is lesser than what? 1000. And it says what? First 100 natural numbers where 100 is not included. It's lesser than 100, right? So now you look at this. When you give this 10,000, so what is the square root of 10,000?
It's 100.
100.
100. So that brings you what? When you take this 100 and you put it over here, put it over here. So 100 is belonging to a natural number. So you see, this is the maximum value you can have, right? Now you take any lesser value lesser than that. That essentially gives you a number between 0 to 100, right?
Okay.
Right? Okay.
Okay.
Sir, can you explain fifth?
Sir, activity response 1.4.
1.4.
Question number 5.
1.3 में fourth.
You asked me multiple times. I told you, like, let's just finish this order, then I'll go there. Okay.
Sir, go down, please.
Number 5. Sir, this
5 you have doubt?
Yes.
Yes. I don't understand what is question is asking. So can you explain?
Basically, okay, fine. So it's basically which among them is correct, like which among the interval is subset of this. It's just asking a subset, right? So how do you do this? It's basically just simply draw a number line and you say this is 2, this is 3, all right. And then what? All we have to do is just match with this and check, okay? So now let's first do matching with the first option, all right? So now you see this, it says what? 0 to, it starts with here. It's like 0 to 2.3. So 2.3 is somewhere here, right? So, and this is your 0. So maybe I can just highlight it in a dotted part, right? So now 0 to 2.3, okay, this is fine. So this will give you what? I'm just doing the first option. 0 to 2.3 is this line. Can I say this? Where this is not included, right? Because it says no, 0 is not included and 2.3 is included. So I can just highlight this in a darker way, right? And it says union 2.2 to 3. So now when I go from here to here and 3 is included, is 3 included? Say something.
Yes, sir.
Yes.
It is included. Now I'm just done with this part. I have represented this part on this number line, this one, right? Now it says what? Intersection of this. Now what do you have to subtract? Intersection, or not subtract, but intersection 0 to 2.3. Now what is 0? 0 is here. And what is 2.3? 2.3 is here. Intersection between them is which region? This region, right?
Yes.
Is this region a subset of this bigger, this region?
No, sir.
No.
No, so therefore this option is gone. Understood? Okay. So now let's take the counter part of this itself and understand this. Now it says what? The other one. Let's go with option C now. I'll discuss option C and then I'll take up option D and then you can understand this. Now I'll take option C. Now you see what does it say? 2 to 2.5. Now where is 2? 2 is here. 2 to 2.5. Let's say 2.5 is somewhere here. Maybe, yeah, 2.5 is here. Right. So now, and is 2 and 2.5 included? Is included?
Yes,
Yes,
both are
it is
included.
So yes, I represented this. Now what about this? Then it says what? 2.5 to 4. Now 2.5 to 4. Now 4 is somewhere here. Maybe I can say this is somewhere here. Right? So I am done with the representation of this, right? Is this a right representation here for this? Yes, right? Now it says what? This symbol tells you what? Minus, right? So from this number line, you are subtracting what? 0 to 2.3. Where is 2.3? 2.3 is here. So 2.3 is here. So when you subtract from this line 2.3, so what are you essentially cutting out? This part you are cutting out, right? And you're left with this region only, right? So can I say that this region is a subset of this?
No.
Yes.
Wait, what did I do? I was actually doing option C. I'm sorry. So basically, yeah, it's the same thing. But you see this, can I say this basically we can look at the option B also here. But when you subtract this part, is this a subset of this? The answer is no, because these extra regions are coming in, right? Now look at this option C. Option C is same representation. This part is same. Now instead of this cutting down thing, I'm just not cutting down here. Now you see the representation for this is this, right? No doubt on this?
Yes, sir.
Yes, sir.
Representation for that is that. Now what you have to do the intersection 0 to 3. Now what is 0 to 3? Where are 0 to 3? 0 to 3. 0 to 3 is here, right? So when you do the intersection of this part, when you do 0 to 3, right? So you will be left with what? You will be left with these regions only. Up to here, right? When you do this intersection. You understood how? You understood
Yes,
how?
Yes.
Yes, yes,
Yeah.
sir.
So you are left with this region, and this is what? It's basically the subset of 2, 2, 3, right? Therefore, C is right. Correct? You understood now?
Yes.
Likewise, you can solve this and understand. You just have to play around with this number. Clear? Okay, so now let's move on to the next thing and see what doubt you can have. So over here,
Sir, go for activity number 11. I have lecture.
yeah, fine. I'll just finish it up. Here, this is just Venn diagram thing. You can do it, I guess. There is no big problem. Just do the Venn diagram. You can understand that. I mean, if you haven't seen the lecture.
Sir, will you just share this activity question solutions?
This is basically not a solution. I won't be sharing with this, but I'll be sharing with the other slide. Yes.
Sir, I have a problem with activity question 7. This Venn diagram one.
Which one?
First one. First one.
First one itself you have doubt. Okay, let's see.
Sir, I have a problem. Is that 40 student is an universal set or the summation of math, stat, and English? Like here it is.
In a class of 40 students, 20 took mathematics, 18 took statistics, 16 took English, 7 took mathematics, statistics, and 3 took all the three courses.
So,
okay, how many students are not taking any of these courses? So of course this does not tells you that, right? Because when you say 40 students, it's actually there may be some students who has not taken any of these subjects, right?
yes, sir.
Yeah,
So it's
so
an universal one, universal set.
it's not a universal, no? Yeah, you can say actually. Yeah, it's a universal set. Yes, you're right.
Okay, and 22 mathematics means whether it's only mathematics or union is also included. Like
Union
math.
is also- yeah, the intersection part is also.
Intersect. Okay.
Yeah.
Thank you, sir.
Yeah. So now let's go with the next one. Here, so we are entering into relations. So here, I don't think so you should have any doubt over here. You can answer this. I think most of you asked questions on that part, that snail problem. Over here, you can just solve this. Partition of set, this is just a definition. Here, I think you might have doubt. So this is just a direct definition. Equivalence relation, partitions of set. For now, just consider that this is just a part of a definition. You will be dealing more this in a calculus part as you go ahead. So as if now, just understand that yes, equivalence relation, partitions of set. Okay. Rest all things are incorrect. So we are entering into functions also. So okay, but I didn't teach you functions. But still, if you have doubt and if you have gone through the functions, then you can ask me.
Sir, when will you discuss
Question number
functions?
3.
You can ask me if you have doubt in this activity. I can tell you right away.
Sir, question number 3.
Question number 3, you have doubt?
Sir, when will you discuss functions?
Functions will be discussed in the next lecture, which is going to happen on
Sir,
Monday.
could you discuss Venn diagram also in the next lecture?
Sure. We can.
I have a problem with this inject.
But if you have a doubt with this activity, you can ask me with this functions also. Yeah, tell me what?
Yeah, I have a problem with number 3. Like how to solve this one?
Which of the following are true? Okay, so x
Number
plus
3.
Yeah, that's what I mean. You see this? I'll mute all. You know this? You know this modulus function. What does modulus function takes in? The graph or modulus function is something like this, right?
Positive.
Always positive, right? But look at the codomain part of this. All real numbers, right? All real numbers are the codomain. Then certainly this is not what? This is not surjective. Because what about the non-real numbers? I mean, non-negative numbers. This will only give you positive, right? because this modulus will always give you a positive output. But what about the negative values, right? What about them? So that will not be covered here. So therefore, this is not surjective. What about whether it is injective or not, right? How do you understand this? When you give the value, let's say, what do you mean by injective? You should get a unique output, right? Every time. Now look at this part. For an example, take x as equals to -4 and take x is equals to what? 5/2. So yeah, take 5/2. What do you get output? You take -4 and you take 5/2 to this part.
0, sir. Both same image.
So see, is this an injective function? No, because you should get a unique output, right? So this is also incorrect. If this is incorrect, then this is definitely incorrect, and therefore this is it. Okay. Clear? Any doubts still?
Sir, just scroll up.
I mean, I don't know whether she got convinced or not. Do you have still doubts here?
Yes, sir. Okay.
Sir, scroll up.
Tell me.
No, sir, down. Sir, down.
Are you bringing me to the activity 1.11?
Sir, Sir, can you explain this question, sir?
Yes, sir. This one, 6th number.
So now the 6th number, how is this done, right? So let's go with the first option, right? So now you see this, this is ax plus b. So a is 0. So if a is 0, then okay, I'll just draw this Venn diagram. Sorry, this arrow diagrams and then explain you this. Ax plus b is 0. A is 0 means what? What is my f of x? F of x is b, right?
Yes, sir.
Right. So now this is my this is what we are getting. This is x and this is your f of x, right? And this is mapped from here to here. So now your when f of x is equals to b, now b is something, some fixed value, isn't it? B is some constant value, isn't it? Let's say b is 5. Let's say what? B is 5. Now no matter what x value you give, it will map where? To 5. Right? Understood? Because you see, you can write this essentially in I'm telling you about the first option. So you can write this in this way. No matter what x value you give, what will be the output for this? B?
B, yes.
B will be the output, sir.
So is this a bijective relation? Or is this an injective relation, first of all?
No, sir.
It is not.
No, sir.
And is it surjective? No. Because it is from, from Z to Z, right? Therefore, this is not, this is incorrect. Now look at this, option B. What about this option B? Option B is something like this. Maybe we can just, this is next to, I'll erase everything and then I'll say that. So now what do you get from here to here? What do you get from here to there is, now you see this. Your A is what? A is any value between? So
-1 and
A
1.
is, it's not between, but it's only two values, -1 and 1, right? And what about your B? B is some integer, isn't it?
Yes, sir.
Yes, sir.
Now, if I happen to take f of x is equals to, if I take A as equals to -1, so it becomes what? -x plus B. B is what? Some integer. Let's say it can be anything, no? It can be either 0, it can be 1 or -1 or whatever. Right? Let's say it's, yeah, -1. So now what? This is a linear function, right? So linear functions will what? They'll have a unique output, isn't it? You will have this kind of condition coming in, right? Or if you can take it in the other way around, f of x is equals to plus x -1, right? So then what? Then what also, you still get a unique output, right? So this forms in bijective relations over here. So this is something, right? Now look at this options. Now again, this is A being 0. Now if A is again 0, it was similar to this. You will land up here, right? So this is incorrect. And look at this part now. Look at D part. So what is happening with D option? Again here B is being 0. But look at this now. If I have to draw, if I have to just rewrite this function, what do I get? F of x is equals to what? A. Now A is what? A is an integer and A can be anything, right? A can be 0.
Yes, sir.
Right? So what? No matter what, whatever x value I give, if I give 1, 2, 3, 4, what is the output I'm getting? I'm getting 0. So the math here, so that this becomes wrong. Sorry, this becomes wrong. Right? So I hope you got it. Okay, so now let's
Sir, sir,
yeah, please.
can you go up? No, I mean, the fourth question.
Yeah, I get it. Sorry, yeah.
Sorry,
Yeah.
Fifth question. Fifth question,
yes.
How is A a correct answer?
Because you see, by the very definition of this, the A is, how is this injective, is it?
Yeah.
So you see this, first of all, you know what is the injective functions?
Yeah,
single values of x should give you single values of
a one-to-one relationship.
Yeah, one-to-one relationship, right? So this is definitely going to happen, right? Because no matter what x value you take, can you have two different x value giving you same output?
But again, it's very ambiguous, right? My codomain is not defined, right?
Where x belongs to R. So you see this, you can
go into the complex number realm, right?
But this, we are talking about injectivity. We are not talking about surjectivity. So you don't worry about the codomain part.
Oh, so injectivity can still the codomain need not be.
You don't have to. You don't have to define codomain for.
Okay. Yeah. Thank you.
So can you please go to activity question 1.6, question 7.
Okay. Now I'll go for that later on. But let's just finish this order. Now, any doubt over here? Any doubt? No doubt. I guess these are easy. Are you going to answer? You have doubt here?
Yes, sir.
Tell me.
Will there be only one class for every subject per week or more?
Okay. There are 3 live sessions for Maths 1. Per day you might have. Per week you will have 3 live sessions.
हो. और वो पीछे वाला मुर्गा आपका है जो बोल रहा था कुड़कू.
Hello. Okay, so now just tell me, what about this part? So over here you don't have any doubt, right?
Sir, I have a doubt in second one.
Second one.
Yeah,
what doubt you have?
This process.
What doubt you have here?
Third question, second part.
Yeah, what doubt you have here?
Yeah. Why not A be the answer?
What is the set of possible cardinalities of P? What is P here? P is a subset of this, right?
Yes, sir.
So a subset can also have, it can have, but which is the best among them? I mean, certainly you can say that that is right, but you have to choose the best suited answers here. That is what. Okay.
Here, empty set is represented as 0.
Yeah, right. Because they are asking you cardinalities, right? So you have to choose the best one, right? Of course, it can be the possibility is there, but which among them is best? That is something you have to choose. Okay. So now somebody was asking about that 1.11. So I think we have approached there. So yes, tell me. Which question you have?
Question 2, sir. Question 2.
First question.
I have doubt in question number 2.
Yes,
sir.
First question, anybody? So
I have doubt.
So in this, you have to make sure that this is not equals to 0. For what value this denominator will not
In
be?
question number 2, the product of the minimum value of the function.
I'll come to that. First of all, you tell me what is what about this? 4x minus 8.
Except 2.
X not equal to 2.
X should not be equals to 2, and that is something mentioned here. So that's it. You have to make sure that this is not equals to 0, because when it becomes 0, then this will become not defined, and that is something we should have. Okay. So what is the product of minimum values of these functions? So see this. What is a minimum value for this? This modulus function. What is a minimum value of a modulus function? 0.
Yes, sir.
0, right? So the minimum value of f of x will be what?
Minus 8.
Negative 8.
So that's going to be minus 8. And what is the maximum value of the function, this one? So when will this be maximum? When this becomes 0.
0. Yes, sir.
Right? Because you are essentially you are subtracting something from this, right? So if this is the least value which you subtract from this, then only it becomes. So what is the least value of this modulus function? 0. So therefore 11 times minus 8 is nothing but 8. Understood?
Yes, sir.
I got
Yeah.
I got it.
Now what about the other things? Do you have doubt anywhere else?
So the third question.
There is 7 question.
Third question, yes, what doubt? Tell me what is your doubt here?
7 and 8.
No, third. You had doubt, right?
Yes, sir. How does the root function become non-negative?
See, because root functions is defined only for a positive greater than or equal to 0. Root of x, where x is always greater than or equals to 0.
But,
that means the output for this is always positive. Likewise, the modulus function, the output for this is always positive.
But the condition does not apply for the second option, right? Like, I mean, the condition is nowhere specified, right?
No. You give any negative value for this. You give any negative value. You give minus 10. What will be the output of f of x? 10.
Complex number.
No. Here in option B, I'm talking.
No, not option B. I'm talking about option A. Option B is clear.
Okay.
Option A, if I give a negative number, which is greater than 15.
Okay, could you tell me what is the domain of this f of x?
It can go into the real number domain, right?
It has to go in the real number domain.
No, sorry, complex number domain, right?
No, it cannot. Because you are violating the definition of this function. First, identify what is the domain for this function. You have to make sure that 3x plus 15 should be greater than or equals to 0.
Equal to 0.
The natural numbers, no, sir.
Yeah. No, just let's go with that. So for what value it is going to be greater than or equal to 0? So when x is what? Greater than or equals to minus 15 by 3.
Minus 15.
So if you draw a number line and if it is minus 15 by 3, so what is the domain from this to this part, right? So minus 15 to 3 to infinity. This is the domain for this. Now in this domain, now you substitute any values, it will always give you positive.
Okay, I got confused because there was no mention of the domain.
No, but you have to respect the definition of that particular function. And that's always throughout. You will have to, yeah.
Okay, thank you.
But sir, in one of the previous question, you said that no worries about codomain.
Yeah, I'm not worrying about the codomain. I'm worrying about the domain.
But sir, we restricted the domain only on the basis.
That was about injectivity. She asked me about injectivity. In injectivity, you're not worrying about the codomain part.
Okay.
Yeah. Okay.
Question number 7.
Question number 4. I don't get the question number 4.
Yeah. Why? Why you didn't get it? Take an example 1 and 2.
Sir, I was disconnected for those examples.
No, I did not discuss. In fact, take an example 1 and 2. When 1 is odd, right? Right. 1 is odd, right? So I'll be using this. If this is my.
We get the same value, sir.
That's what. No? So this is f of x. So f of n. Sorry. Yeah. So this is f of n. So when 1 is odd, right? So when you substitute this value, what do you get output? 1 plus 1 by 2, which gives you 1.
1.
So something like this. What about 2? When 2 is even, so you
2 is even, so 2 by 2, 1.
So what is this onto? Cannot say anything about onto as if now. But is this 1 1?
No, sir.
No, sir. It is not 1.
It doesn't have a distinct value.
This option is gone. And what about this? Is it 1 1? So yes, it is 1 1 1 1. But what about onto? Let's check with that. It is 1 2 1.
Sir, it is not 1 to 1.
It is
not 1 to 1. Yeah.
It is
this is not 1 to 1. This is not. So this is definitely. And what about onto? So onto it's definitely going to be because it's a set of natural numbers, right? So when you take 0, so which is the number you'll be choosing? Right?
0 by 2 0.
So 0 0. Right. So that's how. Yeah. So that's how it's. Okay. So now let's go down. Any doubt here?
Sir, question 7.
7.
The 6, sir.
Question 6 is similar type. All you have to make sure is
greater
than 0. You have to make sure that 14 times this 3x plus 35 by 5x plus 4 is greater than 0, greater than or equal to 0, and solve this inequality. That's all. You'll get the answer. Is that okay? You
Yes,
can
sir.
solve it. You can solve it. Yeah. Over here, okay. So now what? First of all, you have to understand what is range and what is your domain. So x, when you write x, y, right? So when you say this, y is equals to x, suppose. So x is what x talks about domain. And whatever you get outside from this is nothing but your codomain. So basically this axis represent what? Your codomain, your domain, right? And set of output values, when you substitute this x to the function, whatever the values you get outside, that is your what? Range for that, right? So range is what? Range is represented by this y, correct? So what is the domain for this? What is the set of x values it is taking?
2 to 6, 2 to 9.
Minus 4 to 9.
4 to 9.
Minus 4 to 9. Yeah, minus 4 to 9 are the set of x values this function is taking. So your domain is what? Your domain is
minus 4 to 9.
Minus 4 to 9. Right? And what about your range?
1 to 9.
1 to 9.
Is it 1? Yeah, 1 to 9. So 1 to 9. So what is the question asked? Are mn m comma x. Now the domain and range of the function is shown here are m comma x. So m is this first thing and this respectively. So now you can identify, right? What is your m? Minus 4.
Minus 4.
What is your n?
9.
1.
1.
Right. So what is the value of m and n? Minus 4 is 1. Right?
Yes, sir.
Likewise you can say. Yeah, so I think this is done for this.
Sir, say about range again.
Range is nothing but the set of y values what you get. Set of y values. Okay, so I think
increasing, sir. Increasing value, na?
No, don't go with increasing values.
Peak values.
Extreme values you can say. The set of extreme output values is something is your range.
Like 3 and 1 is initial and 0 and 9 is final.
I didn't get it. Come again.
Sir, a range is starting from 3 and 1 point. That is the 1. And 0 and 9 is the last. That the 9 is the last.
So which value you will be taking? You will be taking the y values there.
Yes, sir.
Right? Understood, no? Okay, then we can end our session.
So finally,
thank you, sir.
One doubt. Sir?
Yeah, tell me quickly, and we can just, because we have
it's related. It's a little clarity I just needed in the power set, as you said in the description of power set. If we having considering the null set also set, there will be 9 total cardinality, right? For example, as you said in the power set of description. Considering the null set and 1 and 2, 3 and 1, 2,
it won't be 9.
2,
it will be 8.
That will be. But also because if the power set describes the all possible combinations will be the cardinalities, right?
1, 2. Now you have to list the power
for
set
example, from that only I'm just asking.
Okay.
As you said, we could have the 3, 1 and 1, 3. Why we can't have the 3, 2? As you said in the descriptions of the beginning session of power set.
Okay. See, it's because you see this power set is nothing but it's a subset of sets. I mean, it's basically a set itself, right? So when you say this, when you have this power set, it's basically a set which contains a set, right? So it contains what? An empty set. It contains set 1. It contains what? Set 2. It contains set what? 1, 2.
1, 2.
Right? It contains what? Anything more? You mean to say, can I write this 1? But it means the same set, right? That's why you don't write it. That's why we don't write it.
Okay. Even if it is being getting into 1, 2, 3. So as you said in earlier, you have been described as 3, 1 also in the set.
And 1, 3.
So yeah, 1, 3 also you have been getting.
No. Then I think that might be a typo from my end. If I would have done, but I guess I've done that.
I think you have been done, and in that.
Where, can you tell me where is that thing done? I'll just.
In the power set of beginning of after the sets. little bit above. Yeah. So you have been in A5, you have been given 1,2, or you have been written as 2,1. But in A7, you have been given 1,3.
Where is it 1,3? It's 3,1.
Sorry. Okay. Sorry. I just mismatched. Sorry.
Okay.
Fine. Thank
Anyways,
you.
so thank you all. And we can meet in
Thank
the
you, sir. It was a great. Thank you, sir.
Sir, when is the next live session?
Next live session is going to be on Monday.
Thank you, sir.
Bye,
Sir.
Have a good
Thank
day.
you, sir. Thank you, sir.
Very useful.
Sir,
Thank you,
whether
sir.
all the sessions in the next months will be also having the same timing in 7 to 9?
Yeah, so activity timing will be 7 to 9 and the rest all will be in the evening. 6 to 8
Thank
and
you,
one
sir.
is 8 to 10.
So will you be
Okay.
conducting a session on functions by Monday?
Yeah, Monday.
Okay, thank you, sir.
Thank you, sir.
Thank you, sir.
sir. Bye.
Sir.
हेलो चले गए तो भाई लोग काफी अच्छा रहा आज के क्लास शाम को सीटी का भी है 8 से 10 मिलते हैं फिर सीटी का मेरा हो गया है हेलो सारे सो गए हेलो
Thank you, sir.
अरे कोई बात नहीं मेरे बच्चे हेलो दिव्यांशु हेलो